Is this thing on? All right, cool. Hey everybody, let's get started. I'm Steve Allison. I'm the GM for the Epic Game Store here at Epic, and we're going to discuss the evolution of third-party app stores and really get the insights across all the different folks here at Aptoid and the Alt Store, and also leave some time for you guys to ask us some questions in an AMA style. Just ask us anything. We'll do our best to answer it as long as we can. And let's jump in. So the first topic is you guys are here at UEFest. This is an audience of developers. We're all App Store operators, and Tim, our CEO. And let's start with what's your pitch to developers to go outside the App Store and Google Play Store and mobile and come to Aptoid or Alt Store.
Good morning, everybody. So my name is Paulo 300. I'm the CEO and co-founder of Aptoid. Just very briefly, what is Aptoid? So we are an Android app store and now iOS app store that exists since 2009. We started much based in the community, open source, GPL, and so on. And over the years, it grew. Now we had around 40 million monthly active users operated across our different app stores and network of partners, Aptoid, Aptoid Games, GamesHub, and so on. And about the pitch, I guess that for us is providing developers with more users, a channel to reach new users and getting more, enlarging the user base besides Google Play and Apple App Store.
Okay. Hi, everyone. I'm Riot. I'm the founder of Alt Store. And just very quick background. 10 years ago, I tried to distribute my app, Delta, in the App Store, but it was rejected because Apple didn't want video game emulators allowed in the App Store at the time. And I thought that was kind of dumb, because I just wanted to play Pokemon on my phone and other Nintendo games. So I spent the next few years building out Alt Store. And then earlier this year, we finally released Alt Store PAL as an official app store in the EU with Delta as our main app. And it scared Apple so much that they ended up allowing us to put Delta in the App Store too. So that was pretty great. And so yeah, the pitch for us is we're all about indies. It's just us two working on this. We built this whole app store ourselves. We want to make a whole app store that's meant for other indies that can just put their apps out there without having to worry about Apple rejecting it. Because we kind of just want to be like the 90s when you just put anything up on the internet, like shareware, and just get it out there for free. And so we think that's great.
And so hi, I'm Shane Gill. I'm the co-founder of Alt Store. And so kind of along the lines of what Riley's saying, we're very indie focused. We have built a Patreon for ourselves, and that's how we've funded everything that we've done. And we're kind of here to show that you can do things a different way. We've used Patreon as our whole monetization strategy in a way to promote developer first in our store. And we've used that to do early access is how we monetize ourselves and just kind of showing you can do something different than what the App Store allows, and you can do all sorts of things. And we're really just promoting these ways of getting developer-focused stuff out there.
Thanks, guys. And for us, from my perspective, I would say our commitment to scale so that you all have additional options is really, really critical to us. And then the opportunity, with scale, to earn more of every dollar, have alternatives, and we have so many exciting things coming up where you'll have the opportunity to maybe push even your existing users on other platforms to options on the Epic Game Store to earn more revenue in much the same way you might on Coda Pay or Exola web shops. And we can't wait to get to that later, but scale and opportunity are our biggest for us. All right, topic 2. What have you guys learned building your own mobile store that other developers considering jumping into this space should know before they jump in?
So I think a big thing for us is it's just Riley and I. We're the whole company of Alt Store, and so I think we're here to kind of show even a small company can do it. If you have the idea, you should go for it. We've been able to get through everything that Apple's put in front of us is how to launch an iOS app store and do something different. And I think that shows sort of anyone can do it, and we're really here to promote that idea.
Yeah, and honestly, it's just way easier now than when we started all this. We started this 5 years ago, before there was a law to make app stores a real thing. And to have a conversation about why you want an alternative app store just was really hard to have with people, because we're so used to living in this app store, at least on iOS. We're used to just having the app store and thinking all the apps are in there. And to try to tell people there's a whole world they're missing is just really hard. But yeah, now that the law's passed and we've been able to establish ourselves, it's a lot easier. The momentum's building, and so I think it'll just get better with time.
I'd say one of our lessons, and I think it's been taught across the industry a bunch of times, is if you have a really good game, people will go to your website, they'll download your game. If you want to launch your own store with it, people will download that too, a store or a launcher. Like Riot Games launched League of Legends through their website, and that's, until they came to the Epic Games Store, that was the only place to get it, because they didn't want to put it on Steam and give 30% of their revenue to Valve. We did it with Fortnite, and it totally worked. We just got all of the users we wanted. Genshin Impact launched on their own website, reached a huge user base, and then they came to Epic Games Store and reached more, and never had a gatekeeper forcing them to hand over a percentage of their revenue. They've been free to make their choices. And if you look back even further, 18 years or so, a little company called Valve launched their own game through their own launcher and their website, and then it became Steam. So you can do it. And if you have a great game, you don't need the gatekeeper. And guess what? The gatekeeper might have a huge audience, but they have an even huger number of games that are competing with yours. And so direct-to-consumer is a really viable thing to consider.
Follow anything there? Or?
No, I just agree. So there are business cases where direct-to-consumer self-distribution makes sense. There are other cases where you can distribute it through an app store. I truly believe in the mission of the app stores. I think we play a role in the ecosystem, a positive role. And what is that role? There are 7 billion people connected by mobile phones. For them, most of them, the mobile phone is the first device to connect to internet and get information, leisure, and so on. And having just one store there does not make sense for me. One store in Android, one store in iOS. So we play the role to help developers to reach out users. And an app store is just not a dummy thing where you go there and search for Spotify or for Fortnite, because for that you go to Fortnite website and to Spotify website. You don't need the app store. For me, the story is to help discover the best games and the best developers for the users that don't know all the developers, right? Sometimes it happens, I want to try a new indie game. And then the App Store should help. In the past, it could help, and today it's just a matter of paid acquisition for who runs the current App Store's incumbents.
Great, thank you. All right. This question, this topic, what do you think are the benefits for app developers that are looking to offer their apps on third-party app stores, and what might be some of the downsides? Tim, I'll flip that one to you to maybe kick us off there.
Well, each store brings its own audience and its own flavor. The Epic Games Store on PC was defined by the Fortnite audience initially, people who a large portion of whom had never used Steam. They were people getting into gaming because their friends were playing Fortnite, often on console, and they were coming into gaming on PC. AltStore has an audience around people who are fans of emulators. There's different audiences, and the one store that has everything is a ferociously competitive place, and their ad fees are insanely high, and the more the better, generally. If you're going to ship on stores, ship on all of them. That's been our strategy. As soon as we were able to launch on mobile, we support all of the stores that were awesome to developers.
No, I mean, just like that, I think there are so many advantages for developers to be putting their stuff on other stores. And I think we're kind of seeing it today. Like, the mobile economy has kind of just gotten stagnant. And a lot of this is just because there's no room for innovation, really. Like, at least again on iOS, Apple rules the App Store with like an iron fist, and it's hard to ever push the boundaries of what's allowed. And so we end up just not really going anywhere interesting beyond what Apple's controlling. And it is in big ways and in small ways. Like, one of the other apps in AltStore is another app I made called Clip. It's a clipboard manager. It just runs in the background, and just like whenever you copy something, it saves it, and you can paste it whenever you want. That kind of stuff isn't allowed in the App Store, even though it's a very useful thing that a Mac can do, that a Windows PC can do. And so we just think there's so many ideas like that, just like Clipboard Manager, or so much bigger, that could exist. And we just haven't seen them yet until y'all put it out there.
Yeah, and I think to even add on to that, like, we offer other ways that you can, monetize or how you want to do your project. Like, you can really do it yourself in a different way. And even though Apple has one way of doing things or Android has one way of doing things, having more different stores just means that everybody can kind of figure out what makes sense for them as a project, and you can really like custom fit what you're doing. And just having those options means that you now have that ability.
Yeah, I would highlight an extra point about the benefits, which is the mobile industry is changing a lot and very quickly in terms of apps distribution. Steve talked about the Digital Markets Act in Europe, but the MCC in UK. In Japan, they passed the law. So what is today the landscape of apps distribution will change a lot in 2 years. So self-distribution, alternative app stores, and the learning curve will take time to understand the best business cases for each case. When is better to self-distribute? When is better to do paid acquisition through Meta Ads or Google Ads directly for alternative app store instead of Google or Apple? And to learn that, being first mover is important in my opinion. So I would say that the advantage to jump in early is also to know. Like the Zing and Farmville back in the days of Facebook when they discover a space that nobody was looking into it. I see the same opportunity for the developers that take this first step and try to understand better this world of alternative app stores that is emerging.
Awesome. All right, our next topic. So what are the benefits for consumers? I'll kick this one off. From my perspective, we have great benefits for developers. We're very clear with that. We go into places like UEFN and GDC, and we sort of make that clear, and we're always in conversation with all you guys. But a lot of that question does come up, and I think in the case of mobile, my personal opinion and the opinion of much of our team is that the App Store and the Play Store are fairly joyless places to look for things that give players joy. It's turned into a spearfishing app where you generally get hooked by UA, and then you come in and you type in the name of the game that you saw the ad for, and you grab it. And that's super effective and fun, functional, but it's not fun. Digital retail, our human nature, we like to discover things, we like to browse things, we like to shop. Those stores today don't really offer that, and we want to, at least in the case of the Epic Game Store, we want to bring joy back to digital retailing. It sounds corny, maybe it is, but it's a real thing. Like all of us, we build things that make people like super happy and stoked and like spend their free time. We want our place to be the place where players who care about that kind of stuff want to go shopping. And things like our free games program, we've always designed it from jump to be like, hey, we're going to offer games that some of them have sold great and they work really great for user acquisition, but we also want players to discover games they might have missed from developers that are awesome and become fans of those developers. Bringing that program to mobile, I think, is going to be super cool and really benefit people who are making mobile content. So those are two benefits. I could go on for an hour and a half, so I'll stop there. Now, if you guys or Tim, you have any thoughts there?
Sure, yeah. No, I think you nailed it. Yeah, we're trying to bring fun back. I think that's a really important thing. Just the mobile economy, just phones aren't fun anymore. Everything's boring. We just want to bring some fun back. And like, we're trying to bring emulators. We want to play Pokemon on our phones. We want to play Mario on our phones. Crazy stuff like that. But then I also think I should point out, this isn't just benefiting consumers who are using alternative app stores. Like, again, Apple changed their rules for the normal app store to allow emulators because we launched our app store. So now around the world, people can now download emulators because of that.
So you guys made change happen. Like,
exactly.
That's a benefit for players, right?
Worldwide competition, what a concept. And then additionally, like a couple months ago, it happened again. We tried to get a virtual machine app into Alt Store, and then Apple was a little threatened by it, and so they changed the App Store rules worldwide, so now you can install Windows and on your iPad and everything just through the App Store. And so, yeah, I think it's just good for everyone, whether you use an alternative app store or not.
Yeah, and I think even to add on to that, I come from, I used to jailbreak my phone in high school and do sorts of crazy stuff, and come from like the modding community and people who used to use devices for, whatever kind of idea you could find on the internet and whatever cool projects people were doing. And I think some of that's been lost through sort of the top-down control that Apple has and just app stores have in general. And opening it up to more app stores just means that more of these ideas are going to come to the surface, and people will start experimenting more again, and people can kind of have fun with their devices the way that, I remember, and people had lots of fun having, like some of my best times were just like going like, oh my gosh, I can do this. I didn't even realize, and I think some of those moments have just like kind of gone away, and everyone's a bit more complacent now with like how things are. And I think just now having this open just means there's much more excitement, lots more fun, and we're really just trying to push that forward.
I agree. I would just kind of wrap up saying that competition drives innovation, competition drives better products. And what can be a better product for a user, a better app store for the user? Well, first could be more specialized app stores. I think it will happen, more specialized app stores, not like 1 million apps, 3 million apps, but maybe specific RPG games or specific for a specific country with specific content. The second is, of course, the fees, the revenue share, and so on. That would impact the developers, but also the users, is obvious. Competition drives less margins, less profit. And third, I would say that is support. Big spenders have a kind of a relatively good support, but the other users, I don't have a good support in terms of the Apple's and Google's App Store, and that reflects also in the customer support for the developer. I think that can also improve.
I also, just to circle back too, I also think there's some opportunities that have just been missed in the space. And in the case of what we're doing on the Epic Games Store, with the multi-platform store approach and connecting users across platforms and ecosystems, and then having we're going to have lots to talk about in the future about Metcalfe's Law and the social platform that we're going to bring is going to be really, really cool. And so users getting that experience in mobile that they just haven't ever gotten, which is thing that they do on consoles where they can party up with their friends outside of the games they're playing, chat with their friends. And in the case of the Epic Games Store, our plan is to enable chat and social parties across mobile devices, a friend on an Android device, a friend on an iOS device, and a friend on PC, maybe not even playing the same game, but connecting with each other and talking about games and eventually playing games together, of course, but more utility than you currently get out of the big guys right now. Let's talk a little bit about what is standing in the way of effective competition, and Tim's probably the biggest expert here, so I'll let him speak on that one.
Gee, I think their names are Apple and Google. So, like outside of Europe, Apple just doesn't allow competition. Like that's an insane, and we thought blatantly illegal policy, but we lost Epic versus Apple US on that topic. So. Somebody else has to fight and win that one in the future now that it's ever more clear what they're doing. Google nominally allows competing stores on Android, but Google is much more insidious than Apple. At least Apple tells you, like it's written in the rules, you're not allowed to compete with us. Google says you are, and then does all kinds of crooked things to block you. You just go to install the Epic Games Store on a Samsung Android device, and you have to go through 21 steps. In which they lead you to this page in the settings, and then another page in the settings, and then you're stuck in a dead end and have to navigate your way back through 21 different steps. And some of the steps just lie to you. Some of the steps say, the Epic Games Store is from an unknown source. Well, like Google definitely knows who Epic is. Quite sure of that by now. Another one of the screens says that our software might harm your device, and it won't. Google knows it won't harm your device. I'm sure they've looked into that. Such as the Google Fortnite task force, the secret team they assembled to try to undermine Epic, looked extensively for that. So just the blatant dishonesty there is a big problem, as well as both Apple and Google's willingness to just ignore the law, to interpret the law in completely disingenuous ways as cover for openly breaking the law with a cover story. And until regulators and law enforcers crack down on them, we're just going to see a completely broken market here. At least we have some semblance of functionality back up and restored in Europe, but it's still highly, highly impeded by Apple and Google's scare screens and bad practices and attempts to attach junk fees to things and just make it really, really hard for competition. But this is what we're fighting over, and it's what we're fighting for, and we'll keep fighting on until it's solved.
You guys, anything?
Yeah, exactly. Nailed it. Yeah, I mean, Tim fully nailed it. Like, it is primarily this Apple and Google standing in the way, so I don't need to say too much more about that. Just from our own personal experience, we really tried to work with Apple when we first started. We really wanted to be on their side, and we wanted to say, hey, we can coexist with y'all. We don't need to be your enemies. We can just take the apps you don't want from the App Store, and we'll take them. And they just did not want to give an inch at any point in this whole process. They really went in kicking and screaming. And so we really had to reevaluate our whole plan of like, okay, I guess they really don't want to be open about competing, even though they are legally mandated. it's very much ingrained in, at least for Apple, that they are not wanting this to happen. So yes, it's a constant uphill battle dealing with them. And just one thing people don't know is they still have to review all the apps that go through AltStore. So they still could reject any apps that we're distributing ourselves. So yeah, I could go on a lot more like Tim, but I'll stop there.
If I have to summarize in one word what is standing in the way of competition in Google and Apple, that word for me would be friction. So Google and Apple protect their monopoly through friction. And that friction is all the screens, all the things as a user that you have to go to side loading. This morning in Twitter and in the topic of the new legal cases that Epic raises and that I fully agree against Samsung and Google. I was with a VP of Google, and he says, no, we are here, and we are doing this friction to protect the users and to have a safe ecosystem. And there is and I think he's a smart guy, and I think that team does a good work, but there is something basic that I cannot understand why a smart person can say, which is, if Google Play Protect knows the signatures of the developers and knows the MD5 of the packages, right? They know, they put it in Google Play. So Google Play Protect have that database. How do we need so much friction to sideload an APK of Fortnite? It's so well known for Google Play, right? It's safe. You don't need to put 4 or 5 screens saying that is potential malware, right? So this friction, I think that is so obvious that needs to be reduced in the future. And if it is reduced by the push of the regulators or courts, because they will not do it by themselves, then I think that we'll see much more competition that will benefit developers and users, of course.
I just add, like those steps, the screens and all the steps that are designed to put friction in front of the process. In our case, our experience is like we lose half the people that intend to install the store. They either get lost on the dead ends, or they get scared by the screens, or they just get impatient. And getting people to drop out by design is not a really great thing to do. Getting people to be informed is really useful if they're worried about security and truly unknown apps. I think that's all fair. But like everyone said here, they know that the apps are here. They're notarizing our content. I mean, our comms team says it, and I really like the way they say it. It's like we want the computer in your pocket to work like the computer on your desktop with like notarization, where developers are trusted, where we don't have to have all these steps, and we can get content to players with 2 or 3 steps instead of 21 steps. And last, before we sort of head to, hopefully you guys have some questions for us. Otherwise, it'll be a little bit shorter session. Can anyone share what's next? You guys want to share what's next for Aptoid and AltStore? Apollo, you want to?
Glad to do it. So what we are launching Aptoid games this quarter. So it's a specialized app store for games, curated content for games. And we are launching also that with different versions in Japan and outside, because we are looking into how can we kind of curate and shape the app store for a specific market, in this case, Japan. It's an experiment, and let's see how it goes. The second thing we are doing, like everybody else, but I'm super excited with that, is generative AI to help the user to discover things. So we have kind of an assistant where I can say to him, oh, I want to install a game, an indie game, I like this and this game, or I don't even need to say because it's inside the App Store. And he suggests several games, and I can tell me about those games, and I can interact with them. So that's something we are developing and launching next quarter. It's not nothing super genius because everybody's doing something similar, but I think the results are very promising.
And yeah, we're going to be focused on building up our library of apps over the next few months. A few months ago, we released the first third-party apps through AltStore, including like the virtual machine app. And 2 weeks ago, we released the first tools for basically anyone to actually completely self-publish their app through AltStore. And so we're very excited to see that play out over the next couple months, because I think that's where we're going to really start to see a lot of the innovation, when there's just no barriers to entry just to get your app out there.
Yeah, and I think to even add on to that, it's like, we use Patreon. All our code is hosted on GitHub. We recognize that developers are using lots of tools already themselves, and we're kind of just trying to say, hey, just bring what you have already and plug into our store. We're trying to be as hands-off as possible. We're not trying to disrupt your flow and let you just release what you need to and not stand in your way.
And then I've sort of hit them early, but the big things for us coming up next is in the holiday season we'll open up with our first third-party applications. We probably expect somewhere between 10 and 50 of them to be ready. The biggest thing is just going to be implementing payment solutions, so that may push some of these out into the subsequent months. But the free games program will launch in Q4 along with the third-party apps showing up, and we're going to have some awesome stuff for players that will also be awesome for developers because it'll help us scale really quickly. And then self-publishing tools, which means developers can come in without any interactions with us like they do on PC today. Probably in the first half of the year, hopefully as close to January as possible. And then the social framework that we sort of talked about here a little bit later in the year. But then when all those three things come together, we're off to the races, and it's going to be a lot of fun. A lot of work, but a lot of fun. I think we can hopefully you guys have some questions for any of us. Let's open it up AMA style to questions.
Okay, everyone, we have to clear the room for the next session. It's a very popular space. If you're hoping to talk to any of the speakers, they'll be right outside. You can step out and meet them there. Thank you.
Right ahead. So my name is Arjan Brassi. I'm a technical director at Epic Games. You know, my goal is to help people be successful at implementing Unreal Engine, and for that, right, we want to share more about all the things that we have in flight, so that hopefully, you know, you can see what's coming. You don't build your own. If we have something in flight, right, stuff like that, and just share more of the roadmap. So that's his talk. So we're going to go over the entire engine. It's a bit much, so I'm trying to kind of get through it. We don't have that much time. There's going to be a lot of specialist sessions for all these areas where people can go to much more detail on like the 5.5 features and what's coming beyond. And I've pointed out those sessions in the slides, so you can see those other sessions if you want to go to those. Big caveat, as always, it's software development, things will change. You know, I think over the past week, there's so many features that made it not, etc., into the 5.5. So it's always the thing that's happening. We just want to share what we're working on. So you know, instead of just like saying nothing and then you know, you can only see it like 6 months from now or whatever. So let's start with rendering. You know, I thought it was always good to kind of start with the aims, right? Like, what are we trying to do with rendering? Well, it's probably the most obvious feature of the engine that we're pushing, right? High-end graphics quality, not just for games, for all these other uses of a visualization engine. You know, but importantly, right, for us, that also means we want to hit the highest fidelity as possible at 60 Hertz on current-gen consoles, right? So that's a true line that we use for all our development to just keep working on performance. You know, high-end photorealism as well for all these other use cases, virtual production, you name it. It's also part of the efforts. So with all the features, right? Starting with Nanite. So the big focus of the year is to do R&D into foliage rendering. So the problem with foliage is that if you have a huge amount of trees going up to the horizon, you know, the Nanite algorithm doesn't work that well because it just becomes a problem of aggregation of all these leaves, etc. So we're looking at all kinds of approaches to render that kind of geometry detail at speed in the far distance, etc. But the other aspect of it as well is that in close to you, next to the camera, there will be a lot of moving elements, right? If you have to see the trees are moving, etc. So for that, we are exploring nanite skeletal meshes, which is actually hitting experimental already in 5.5. And that's really exciting because we're running all that on the GPU. So we can offload all that stuff from the CPU, and it's much faster to render and even instance animations and such things. The other problem with trees is that if you have tried it, you know, you import like a 50 million triangle tree into Nanite. It takes a long time and it's super huge. So we're looking at a system that we call like a Nanite assemblies to composite trees out of different elements that are then instanced and hierarchically instanced to create a full tree at much lower memory usage and much more efficient uses like that. And then, you know, last but not least, we also have highly requested nanite mesh painting in the editor at 5.5. So that allows you to paint virtual textures directly inside the editor instead of doing like per vertex colors, which is not friendly for nanite. So that's now part of the editor as well. Really excited. Artists are all super happy with that. So yeah, going forward, future, we plan to kind of keep doubling down on the foliage thing. We expect really big updates at around 5.6 time. Which is next year, middle next year. And that will both solve all these issues of like dynamic moving trees, the composition of the trees, the aggregation, but also making this all work with Lumen and VSM. So yeah, Lumen and VSM, that area. Excited to show that we now have this Megalights initiative. They we showed demo off. That featured like I think like 1,700 ray traced shadowed lights in that scene, running on a current gen console. It's early, right? It's experimental. We're going to work on performance and get that to 60 and all that in the future. But yeah, really next leap in the graphic fidelity in that way. Then in general, we were doing a lot of work on Lumen performance, so to run that at high quality scalability settings at 60 Hertz on current gen consoles, and also enable hardware ray tracing at 60 Hertz on current gen consoles with 5.5. So that's also really exciting. Down the line, right, what's coming next? Obviously, a lot of work going into Megalights and further optimizing that, but also looking at like Lumen, like how can we scale it down even further by hitting maybe 2 millisecond type processing time, so we can enable 120 Hertz modes, but also run it better on low-end hardware, mobile, and such things. So that's also in deep R&D for future releases, like not pegged to a certain release yet. Then on Path Tracer, so that is now, I'm going to take a sip of water. Path Tracer is now production ready, so that's really feature complete as well for enterprise and linear content type work. And we have some experimental aspects that we just came in with the new denoiser and volumetric cloud support and such things. Then also exciting that Substrate is now hitting beta in 5.5. Substrate obviously is this, complex materials with like lots of layering, without overhead for if you don't want to do simple things. So you can go super complex, but also do simple things. And in good epic practice, what we want to do to make that into production ready is to ship our internal projects on it. So that's not happened yet, so that's why it's still beta. So over the next time, I don't know if it's going to be the next version or not, we need to kind of get Fortnite on Substrate and release that at 60 Hertz, running with all the bells and whistles and performance before we can call that production ready. And then the last bullet point is first-person rendering. So it's kind of interesting because I always think about Unreal as like the Unreal Tournament engine still, and we're like, yeah, first-person rendering out of the box didn't work that well. So we actually put some time and effort into that. So we now have that ready in like experimental stage. So you can do like you have an anti-clipping approach. You have a separate FOV for your first-person mesh, and then we have a bunch of work that we're still doing for the future with, in the near future, like doing shadowing of your gun, self-shadowing, shadowing of your third-person mesh, and supporting the reflections and those kind of things. But that's cool because you don't have to do these nasty hacks and nasty workarounds anymore to render first-person meshes efficiently. Right? Then on the rendering architecture. So, main focus is to really get to ever better performance by improving renderer parallelization in general, to utilize all the cores and using the new work graphs on PCs. So feature-wise, the other thing that we're doing is we're working on a refactor of the GPU profiler, where the goal is to unify these profiling systems that we have, like stats, profile GPU, insights, and such things, and to support also the modern concepts with async compute and mGPU in kind of a single profiler. So that will help a lot seeing what your GPU is all doing. Then we have support for bindless resources, also highly requested from many content developers, right? Enable much newer artist workflows and such things, so that's coming. And last but not least, here, or no, we have many things, certainly not last. We're working on a lot of shader compilation improvements by looking at the compiling time, so they can do their PSO caching, and generally we're working and decreasing the shader permutations a lot to kind of get performance back into your workflows of just working on the games. Okay, then next. We have ongoing work on like render parallelization, right? So coming with enhanced barriers as well, like CPU and GPU optimizations with DirectX. Further reducing shader permutations by doing efforts on reducing static switch conversion things. And then, another big effort underway for the next time period is a new material editor, where the goal is to make a much easier system for people to make performant materials simply out of the box without having to do a lot of custom work to kind of get them to work at performance in the first place. So, make great materials for non-experts is the goal here. Right. There's rendering. Let's go over to world creation. So obviously, right, world creation, the aims are to kind of, have Unreal be friendly to making these big open world games, and have streaming, efficient streaming out of the box, and have all these workflows out of the box with UE5. So we've been on a journey since 5.0, probably since our first tech demos, and we're seeing big improvements every release. As part of that, we also have the PCG system that we now are going to move toward production ready by next year. And that's obviously a way to kind of add a lot more content via rules and systems like that, instead of just hand placing anything. So that's also allows you to stay in the editor, obviously, and get much faster workflows like that. So big thing now is that we're also going to run that on GPU going forward. Ambitious goal here, right? Like our North Star that we have here is that we want to go to much bigger worlds. And then, if you have an order of multiple orders of magnitude more complexity just with the size of the world or the number of actors, a lot of the Unreal systems don't work that nice anymore, right? It starts to fall apart. So we need to do a lot of work in making such things faster. So yeah, 5.5, we have a feature that we call external data layers, where actors within a world partition can now be associated with like a game feature plugin and can be loaded as such, which makes it much more efficient to load that section without having to load everything, also in memory. Level instance property overrides is a bit of a mouthful, but that's our kind of, our basic early prefab type system. So you can have instances that you have override properties to, and so you can instantiate things and do a bit of overrides. It's not our full-fledged prefab system. That's more what you see in UEFN right now with the new scene graph. But this is at least a way to build big worlds with like instance things. And then also, after many requests, we now have static lighting for world partition using CPU light mask. So that's in 5.5. So future, I think a lot of work ongoing to keep improving workflows, customization, quality, performance, all the things. right? The main thing on performance really is towards streaming performance. So yeah, if you have tens of thousands of objects in a cell and you're streaming it in, you know, we hitch, right? It's too much single-threaded stuff. So there's a lot of work on like, okay, how do we make that faster? Like the adds to world, make that faster, but also streaming out of memory, make that faster, right? And you hit in like garbage collect and whatnot. So there's a lot of work to kind of fix that multiple orders of magnitude problem down the line. Then right now, to set up your world efficiently, you have to build a lot of tools to kind of pack actors together into grouped aggregates and hierarchical instance static mesh things and whatnot. So we want to make tools to make that more automatic out of the box to kind of grab all the objects together and put them in the right cell and all that. So yeah, then on the new scene graph, so that we are doing right now in UEFN, because that's kind of a nice isolated thing that doesn't break everything with the actor and component model of UE right now. But down the line, right, we want to make this a UE feature, and kind of the main road ahead for that is like, how do we merge these concepts together, right? Like, how can we kind of move fully to maybe to like an entity system with that new scene graph while not breaking all the previous content that was built in like an actor component model. So that's the big challenge ahead for us. Unsolved yet. So yeah, PCG. Very excited to announce that we have GPU compute on PCG. So, you know, obviously you can do micro scattering. It can generate and instantiate nanite meshes. So a lot more detail possible, fully running on the GPU. We also have a new PCG graph executor, version 2. That scales better under multi-threading applications and allows you to do async compute on some of these things, so you don't hitch or you don't stall on the thread, etc. So you can have things that take longer without hitching and all that. And that helps for both runtime and inside the editor. So that's cool. And there's a talk. So that's the first call out of a talk here. I think tomorrow, and they'll go into much more detail on the various aspects that they're working on. So yeah, future. So in the next year, we want to make PCG production ready. You know, again, for us, that normally means we shipped it in Fortnite, right? We use it at scale ourselves, right? We had hundreds of people working on it, and we make sure that works super solid. So that's coming next. GPU compute is getting enhancements, and you know, generally we're looking at all the workflows of like, well, how can we do better attribute support, dependency tracking, versioning, all those kind of things. The other thing we're working on is a thing that we call like mega worlds, biomes. So what we're seeing is that obviously you don't want to place individual assets anymore, but more and more you also don't want artists to all have to work on PCG graphs themselves, because PCG graphs become super complex, and so that's not for everybody. So can we create a concept of assets that have built-in PCG on every level and can just be placed with these built-in rules, and can we ship content in our marketplaces, in Fab and in Quixel, whatever, that has built-in PCG rules and all that. So that's an initiative that we're going to announce later next year, but that's kind of the workflow we're seeing ahead of us to just make large-scale world creation much easier with that content. Then on terrain, so you know, I've heard people internally sometimes sigh that our landscape is like the worst geometry that we have on screen, because it's just height field and low fidelity and all that. So yeah, we need to get it to nanite level of detail, you know. And while we're at it, we should probably just make it completely 3D and get like pixel-sized polygons and all that. But that's a huge effort, because yeah, you know, even looking at these things, it's very complex. So there's a lot of R&D going on. You know, we're working on like workflow prototypes and such. You know, memory, everything is under consideration there. But yeah, in the meantime, we're stuck with landscape. but at least landscape has gotten a couple of improvements. So, we have various things. So you can do patches, you can do displacement of your landscape. We have better scalability support for like different platforms that you want to target, but also worked on a bunch of quality of life improvements, because we have heard many complaints that people are trying to import landscapes into Nanite, and that made their PCs blow up. So we had to do a lot of work to kind of make that a bit more friendly and not take like a 500 gazillion gigabyte of memory and whatever. So those are the type of things we also have fixed in the meantime on our legacy landscape systems. So then last thing in world creation is the day sequence. So this is finally publicly releasing, really exciting. So we're using the sequencer to basically change anything based on a time of day setting. So it allows you to kind of basically change anything that you can access with sequencer. We've been using it in Fortnite for probably 1.5 years now. But yeah, this is now a plugin that we're releasing with 5.5. So really exciting as well. And there's another talk on that. So yeah, animation. A lot of work going into animation tooling, right? Obviously, our goal is to push this full animation authoring pipeline inside the editor, bypassing the absolute need, you can still do it, but bypassing the need to use DCCs. Also we're, I think, innovating a lot in like the animation workflows and the tooling, so we can accelerate our tooling much faster. Now we have control over the entire pipeline internally. A lot of benefits here as well for round-tripping times, right? You don't have to go back and forth to other tools, but also like animating in context, right? For if you're working on a cutscene or a movie type thing or whatever, you can animate in Final Pixel. So you don't animate stuff that's in shadow or behind an effect or whatever. So you see a lot of improvements there instead of just like the bouncing between external DCCs. It's an open framework which you can extend, build your own tools with. Hopefully we'll see marketplace plugins and such coming. And generally, right, we'd like to see animation being used by more people. So we want to make it not just for experts. And maybe right now the tools are a bit rough, for experts only. So we're working on like making it more friendly going forward. So yeah. One of our big features, one of our big kind of innovations probably for animation is our control rig efforts. So we have a lot of things going on in flight. What just was added to 5.5 is modular animation deformers that you can add on characters in the sequencer really easy. So that's super cool. A modular rigging framework is getting a lot of quality of life improvements to kind of make that easier to use and refine that user interface. We have skeletal mesh editing production ready in the editor, so that's cool, right? It's another kind of thing that you don't have to do in an external tool. And I think especially if you just have a simple thing, right? You have a simple thing you want to put an animation on, etc. You can just do that in the editor instead of having, for even simple thing, go to an external tool. And then ML Deformer, right, has been used internally by us for quite some time. We've even shipped ML Deformer running on like PlayStation 4 with Fortnite 2 years ago or something. So it's super fast. Right, it's like much faster than actually generating that or running that logic, without the ML part. So we're going to release a sample there, and we're working on like debugging and such tools to make that easier. Then in the future, a lot of work going on to deformer graphs still, right? Allowing like physics rigs and more quality of life stuff. And then we also have a big effort on like retargeting to make centralizing shared skeleton data and profile altering more easy in that realm. So yeah, on sequencer, I think sequencer was due to get some quality of life improvements. So we see that as a kind of main cinematic editing tool that we want to have a more clean and friendly user interface for all users. And we also see that as like a timeline tool for anything that needs a timeline in the editor. So not just linked to purely animation. So in that realm, we also have a thing that's called dynamic sequencer that can react on your gameplay state or your place of actors and whatever. And we want to expand that to support those dynamic elements of the game to enhance interactive cinematic experiences there. So that's in 5.5. Then down the line, what we want to do with sequencer is allow you to mix animations together. So take multiple animations, additively apply them, mask them, put them together, build a new animation directly within sequencer. And also with the work on like the dynamic sequencer and all that work, our plan is to go into like a full branching cinematic dialogue system and support that out of the box. So that will take some time, but we're looking at like requirements right now. We're talking to a bunch of licensees to get feedback because people have built these things themselves, maybe in other engines. So this is kind of the work that we want to keep doing on expanding sequencer functionality. Then animation authoring, a lot of work going on in supporting animation layers, getting to like a focused animation editor mode. I think we started that in like the 5.0 version. It's like, well, can we make a bit nicer UI and hide the things that we don't need? And I think animation is now one of these things. Yeah, we just want to go into animation mode in the editor, kind of hide a lot of things. A lot of quality of life there as well. And we have a physics control component coming, plugin coming that allows you to add like simple physically based controls to an animation blueprint and such. So future, more tools, right? We're using this internally heavily. We get a lot of feedback from all these other different industries as well. So that's happening. We want to get to a more simplified timeline. So both we're making it more complex with dynamic sequencer, but also want to make it simpler for like simple timelines. And then, down the line as well, what we're working on, like animating with physics. So, if you have a physics sim running alongside animating, you get a lot of benefits of like free overlap, free secondary actions, posing with collision and physics and such things. So that's in the pipe. So yeah, motion matching, probably one of the most requested, but also popular things in the previous release. So we since released the sample, which is great. Lots of animation, lots of things for you to go into. But also exciting, we're actually updating the sample. So the moment we have new features coming into the animation suite, we update the sample so we can show you all that stuff running with actual data next to it. In the future, we want to add a lot of new things. So can we have like multiple actor support, like interoperating, interacting together? Can we improve the tooling around like trajectories and such things? So yeah, then general animation systems. The gameplay animations camera system is a way for you to allow camera state behaviors and transitions seamlessly. So it's much nicer to interpolate between different cameras without nasty hacks. Choosers to allow you to allow the game context to drive the animation selection. So you can do like custom things per like character type or per damage state of the character or such things. A lot of work in all this stuff with improving the debugging tool set. So this is hard, right? You don't know why it's playing an animation anymore. So having better debugging, rewind, scrubbing controls that you can connect to your console, even in remote, etc., is really useful. And being able to save the state of your animation system and kind of replay that in an external tool is also on the pad. Also exciting that we now have mutable plugin going into beta with 5.5. You know, mutable generates dynamic skeletal meshes, materials, textures. You know, allows you to make like really complex looking characters. And you know, we'll also get an official content sample. So again, this is very useful for anybody that does customizable characters in any way. In the future, right, we're really working on like enhancing all these things. So yeah. Then the next thing really for animation is you know, very non-creatively called AnimNext. And that's our kind of long-term initiative to kind of integrate all the animation logic systems into a single thing and make the anim graph logic much faster using our rig VM, right? We had a control rig VM that was super fast versus the old kind of animation blueprints thing that was really slow. So now we're kind of integrating that into a single unified system. So this will become our next generation animation solution that will replace the animation blueprint, and hopefully as well, in our first benchmarks it starts to kind of show, it hopefully also reduces or eliminates the need to nativize animation blueprints into C++. So you can just ship the things that you're creating in the editor without a lot of manual work. And then, you know, we want to extend that by with root motion support, right? If you don't have like, you know, if you're more single-player games and such things, and state tree support, etc. So it's all running on the same backend system, and will be much faster. Right, developer iteration. Well, the aims, well, we all know, right? You know, the complexity only increases. You know, some of these worlds are getting multiple orders of magnitude faster. You know, I've been making games for like 30 years. You know, I think I iterated much faster 30 years ago than we do now, right? We're waiting for days on end to see a single change propagate to all devs. It's fucking terrible. So we need to do this better, right? So a lot of effort is on this area to make this better. And you know, if you iterate more and faster, you will reach higher quality as well. Not just because you can iterate, but yeah, you know, you just if you have 10 chances to do something to get to final instead of only 2 chances, you know, you get to better quality. We also have heard loudly that people want to hear our solutions, right? So we want to share more of our solutions with you all, and you know, tools that were internal, pushing them external, right? Better documentation and all that. So especially helping like small and beginning studios with setting this all up. So first section of that we call like build and DevOps. So we have Unreal Build Accelerator now, you know, already kind of a fan favorite, which is becoming production ready for C++, and also now supporting shaders on Windows machines. So that's super exciting. You know, the CI and remote execution aspects of Horde are becoming production ready with 5.5. So that's kind of part of the system, right? It all starts to interoperate very well. And then I think also really exciting is that we now have a thing that we call the UE Studio Telemetry and Horde Analytics. So that's basically a way that all our tools kind of throw analytics that you can hook into your own kind of backend, but you can introspect you know, developer iteration problems across your entire team, right? You know, things like regression in like KPIs like cook times or asset sizes or compilation times and all that kind of stuff. So there's a lot of work there, but you can use that and extend it and put your own backend in that and all that. So really cool. Future, a bunch of work in flight still. UBA still has some improvements coming. You know, we were considering a build cache server that should greatly increase compilation speed again, so that's cool. Horde gets busy idle support, which allows you to run that more efficiently on a build farm, so it can kind of start processes, more processes on the single machine. And we're working on like supporting your work from home and VPN relay type things to enable UBA at home, but also improve network congestion when you're at home and such. Then we have the other areas, editor and target iteration, and we have this whole Zen tool chain there. And a couple things are going to production ready. So the first thing is like Zen Loader, which is really an optimized loading path that will increase performance in all places where you're loading stuff, from like starting the editor, loading a map, starting Pi, but also accelerating the cook processes by using this faster load system. We also have shared DDC for Windows becoming production ready. So the concept there is really that anything that anyone has built on the local network already, that you don't have to build yourself anymore, right? You can share it, you can cache it, and distribute it like that. Then we have the Zen cooked output store, which stores cooked assets in Zen and directly fetches the cooked assets, so you don't have to cook it locally anymore. We have a thing called Zen snapshots, where you can make a snapshot of a build machine and kind of copy that to another build machine, so continue the process, and is much faster to kind of do that. Then we have Zen target platform streaming, which is exciting because the goal is we want to have better on-target iteration times, and for that we don't want to have you to cook, package, copy the files over to your console, etc. So we use Zen streaming to stream the content directly from the editor from your PC to your console and be much faster like that. And it's kind of similar to local reads from the SSD. So it's great for development on target. Then future stuff. A lot of work ongoing, right? We plan to introduce async loading into the editor, so that will optimize startup, loading, reducing hitching on starting the editor, starting Pi, and all that. We have R&D, well, over the past couple of years already, but we have ongoing R&D into like efficient and stable incremental cooking, and we're aiming to make that default. So that's going to be a huge improvement in cook throughput and performance. And the last point here is that we're really looking at like what's the kind of minimal data transformations that we can do to convert content instead of just having to kind of naively go through every freaking a piece of content and cook everything and etc. So we need better dependency. We need that incremental cooking type stuff. And this is kind of a long-term effort, but really high on our agenda. And we're modeling some of this stuff as well on like the learnings we see from UEFN, because obviously that's maybe different, but in the end, if you think of that metaverse, you don't want to recook the metaverse if you change the file format or whatever. So you have to kind of consider much different concepts of like stability of files or such things. So platforms and mobile. So obviously a big part of Unreal Engine is that it runs on everything that has a GPU. And we want to provide these tools that can run and make it scale to any platform that's out there. So in this realm, right, we're working, like I said, on like platform iteration, on target platform iteration, on target profiling, testing, such things, make that a lot easier. And we can't really talk about many of the platforms because of the NDAs. We can talk about mobile, so I'm going to talk about mobile a bunch now. So, a lot Bunch of improvements coming into mobile. I'll go over some of them. Right, we end up with a lot of slides, so maybe I'll just go fast. We want to enable the desktop deferred renderer on mobile and for like high-end mobile, and also allow like mobile ray tracing support on that renderer on mobile, which is nice. General mobile improvements in like there's the normal renderer, maybe not the desktop deferred renderer, or like screen space reflection, and other aspects of forward rendering, like decals and different lights and point light shadows and such things. And we also have experimental lumen running on mobile as well. So that's nice. Down the line, right, we'd like to see if we can run Nanite on mobile, so we kind of unify kind of the content creation pipeline, so the same content can run on all the platforms, and maybe just with scalability, you can tweak the size and the complexity and all that. But that's still like future R&D for us. But considering our big efforts on mobile, we're putting horsepower behind it. So tools-wise on mobile, I think the interesting thing is that obviously you have a lot less memory, and all the inefficiencies of Unreal Engine become much more apparent running on a couple of gigabytes available memory mobile platform. So we have extended kind of memory insight support to be better analyzing where the memory is going, right? We've done a lot of memory savings as part of our mobile efforts to get Fortnite back into the store, because we haven't been able to develop on iOS for quite some time. So we had to kind of claw back a lot more memory after like 2 years of frantic Fortnite development. And that's now in the engine, right? So that will help anybody on basically any platform as well. Then down the line, we want to, generally build much better tools to analyze asset costs per platform, and also making some of these per platform properties more easy to find. So that's a big thing as well, right? And then the last aspect of that is that there are certain core UE systems like fnames, asset catalogs, localization data, etc., that are just terribly huge. So we need to kind of work on kind of decreasing that size, and that's in flight as well. Then on mobile, obviously, if you want to run a device, that should be possible, but because you have so many devices, it needs to be easier to kind of preview all these various devices directly from the editor. So we have this thing that we call the mobile preview, which is now getting production ready, so you can see like the correct output of the renderer at the right resolution and all that, so you can tune your UI design and see that we have further improvements there. And then down the line, sorry, I'll get to that. The other thing is like that on-device iteration, and there we're using some of that console enhancement by just streaming the content to the mobile device instead of, again, having to copy it over with like arcane tools on like Android and such things. So, yeah. Then onto simulation. So simulation, what we say is both chaos and both Niagara kind of combined, right? Really, right? We want to enable dynamic gameplay that reacts to the player, reacts to the changing world. Can be photorealistic, can generate photorealistic humans with like flesh and cloth and secondary motion and all that. And we're starting to use more and more machine learning methods to optimize the content creation, but also the calculation of these simulations. So yeah, a lot of work has been going into that. On chaos specifically, a lot of bullet points, maybe go over a few. You know, the ML Flash and full muscular sims are now can now be created fully in engine, so you don't need an external tool for it anymore. So all this stuff that you see here, you can do completely in the engine and set up. And again, right, this will result in sub-millisecond runtime cost per character on like a console. So it's super fast, and you get like crazy detail and fidelity out of that. We also are introducing with 5.5 a modular vehicle system that allows you like building blocks to create and customize vehicles easily. You know, it can support cars, motorcycles, planes, helicopters, and all that. So that's quite cool. Last but not least on that thing is the Chaos visual debugger that can now look at the state of your physics sim, see what's sleeping, what's actually being collided with, and all that. So that got a lot of improvements as well this time. And then Chaos Destruction has gotten a good pass on like performance and memory usage and editor usability and all that. Then a new thing that we have, we call like the data flow editor, and that's kind of an experimental feature in 5.5 that allows you to make like a procedural, non-destructive asset with like a node-based setup. So, you know, Chaos, Claude, Flash, Destruction uses new kind of data flow paradigm underneath, and Hair will get that down the line. So it's a much easier way to edit those things. And you know, then you know, generally, right, with Chaos, we keep focusing on performance, right? And you know, many things in performance, but especially stuff like, well, when you're streaming, when you're adding things to the world, make that faster, right? Not make it hitch, make it scale to like hundreds or thousands or more objects efficiently, and all that. Then in the future, we have plans to like fully automate and enable the musculoskeletal simulation inside the editor itself. So again, we see a lot of benefits of using ML-trained systems to create these complex things inside the editor completely without having to do all that manual work. And you know, the plan is to be able to apply that to any metahuman, right? So that you can get this fidelity on any imported character. Then going over to Niagara. So you know, we have a bunch of things coming into production ready, such as stateless and lightweight emitters that will take far less CPU and GPU and memory, and also kind of are faster to develop with. Also run nicely on mobile, right? If you have constrained performance, these things work better. So we'll keep expanding that thing. We have improved performance using simulation caches, data channels, and you know, generally aiming to get much more off the game thread, but also reduce the render thread in general. So we have more time to do complex things next to running your game. You know, in terms of improved iteration and UX, we now have an async compilation mode, so you don't have to wait for it, and it just runs in the background and recompiles all those Niagara shaders and whatever. And you know, the stateless workflow helps there as well, so that they'll be much faster to use. And then you know, we also are looking at like improving the heterogeneous volume image quality. So we now have like indirect lighting with like self-occlusion on like these complex sims and such. And we also are introducing new scalability controls to tune performance if you're on like a current gen high-end console and want to run these kind of complex things on console. So yeah, we need better control on performance there. So yeah, the future here is you know, a lot of continued work on workflows and reducing the user friction. You know, the system maybe became a bit too expert level. So yeah, there's a bunch of work there, but also supporting more of these kind of stateless particle systems concepts, and that again also help like mobile and such things. You know, then finally on that slide is as well, like, you know, we find that it's really interesting to have BGG work together with Niagara and vice versa. So you can have like these different sims kind of affect each other and kind of inform each other and can read back and forth. So that's also in flight and interesting. So yeah, framework. So framework is basically all our gameplay systems, right? Which we want to keep expanding, you know, to create these really complex and large worlds, right, in your games. So, you know, we have two big aspects. We want to improve the workflows and we want to improve the performance. You know, workflows, we have things like enhanced input, a mover plugin, modularization of the gameplay ability system, state tree, smart objects, all those kind of things. And then on performance, we are looking at a lot of like things like mass, instant actors, navigation on demand, and iris networking and such. So yeah, first thing is that we're going to talk about the state tree. So state tree is getting a bunch of improvements in 5.5, much more robust event support and support for tags and payload structs in state tree. You know, on the runtime part, we are, you know, we want to run like task in parallel and binding functions in parallel to automatically convert from like input formats. We have a state tree diff tool that allows you to, like, similar to a blueprint, have two state tree opened and quickly look through the changes and compare the changes between revisions. So that's useful there. And then, you know, future improvements in state tree include allowing state trees to be event-driven, have better tick performance, and reducing the overhead of these assets, right? They've grown out of control, maybe. And, you know, many more things like that. So yeah, the mover plugin is coming in 5.5, you know, it's really kind of integrating all this UE5 runtime animation things into a single system. And we keep developing this and making that character mover better. So yeah, this time it's starting to support motion warping, improve animation root motion support, trajectory queries for motion matching and such. Sorry. Then on mass, so mass is you know, our kind of lightweight kind of entity-based kind of game system that we kind of introduced with like the Matrix demo back in the day, and we're seeing more and more use cases for that where we you know, have a way to convert like lightweight entities to fully loaded actor and components and back and forth to kind of have like a far away detail system or a far away sim and a close by detailed interaction system with characters. So yeah, one of these concepts is what we call like smart objects, which we think of that the one-stop shop for all interactions in the game. So we've done that for NPCs, but we're now using like we're working on like client-side predicted interaction for players. So you can also use it for multiplayer games, right, down the line. You know, instant actors is that way to kind of replace actors by mass entities and convert them on the fly. You know, we can see a lot more performance that way in like densely populated open world environments. And we also want to do that for moving objects in the future. So yeah, and then a bunch of work on like spawning performance here and updating and ticking a huge amount of assets. So that's all in mass. You know, the other thing on mass is we want to expose more of the basic UE systems to MAS. So UE or MAS can do navigation, querying, and such directly from that instead of having to use a full actor for those kind of things. Then on networking, so we have Iris that has been flying under the radar for quite some time. Our work has been to kind of run that in Fortnite and see if we can actually make things much faster when we run, instead of the web graph, we run Iris on Fortnite. So now we have shipped it on Fortnite BR. And we continue to develop this. So from a, comparing the performance graphs, we're seeing about 20% average frame time improvement right now compared to WebGraph with like much lower hitch counts. Then in the future, we plan to make NetDriver work better over multiple cores, so get that tick much down. And then we want to make the overall push model much better by tracking per property and maybe even be able to skipping replication state completely in this networking aspect. And then we have a new tool built into Unreal Header tool where we want to extend the uProperty replication options, which would then replace many of the net serialization options. So that will be another kind of improvement, big improvement for the speed of Iris. And then lastly, we want to have like replay support in Iris going forward. So yeah, on to like navigation. So we're spending a lot of time on automatic navlink generation to do runtime and dynamic nav mesh generation if your level is changing a lot and such things, or if the level is too big and you can't store all the nav information on your level. And that will allow like procedure worlds to have much more organic and natural NPC navigation and not rely on all these hand-placed aspects anymore. Going forward, we want to better support the baked nav mesh if you need that for your game into word partition. Right now, that's kind of clunky. And we want to have further navlink improvements for like long-range navlinks or the dynamic generation of those navlinks as well. So yeah, last section is audio. So big focus for us is now getting back on like core feature development with meta sounds. We're getting a lot of new audio widgets, which is always fun because audio designers love their widgets, so we have a lot of dials and sliders and cool things coming. We have meta sound support for scalability at scale, right? For per platform, LLDs on sounds and systems and such. And then a lot of work is ongoing into workflows and UX improvements in general for meta sounds, and also having better debugging functionality with like analyzing tabs and a lot of polish on the UX, and a standalone mode where you can connect it to your mobile or your console and kind of see what sound is playing and where the performance is going, and all that, and with tail recording support as well, so you can just record the last kind of bunch of seconds of your audio and kind of debug that, like why was that playing or sounding like that, etc. Then in the future, the things that we're working on is audio property sheets. Unsurprisingly, probably many of you have been asking for that, which will, basically get it closer to some of the other middleware and have like cascading overridable properties on your sounds and such. And then we are working on a dialogue system as well, combined with like the sequencer efforts on like a dynamic cinematic dialogue system. And we have a thing in flight called Underscore, which is a procedural music plugin that can have you create like turnkey interactive music and such. So I got through it. It's a lot. Dates, what you're all looking for. So 5.5 is out now, yay. Preview 1. Release November, so we're on track on that, so that's exciting. UE 5.6 will be late spring, so June-ish. So that's the dates we're working on right now. We are continually aiming for like 2 releases per year. You know, the end of the year release, like this release, next year is probably a similar time frame as well. So that's basically our rhythm right now, and yeah, that's what we're working on. So roadmap is here. Future part of roadmap has been updated. All the 5.5 features that I talked about are here as well with much more detail. You can leave comments as well. The team will read it. So please take a look, scan the code and all that. I'll leave it up here. And that's it. Thank you.
I got a hot mic. Awesome. Hey, everybody. My name's Daryl Bear. I'm going to do a 5.5 Unreal sneak peek presentation for you today. So hopefully you guys want to see some Unreal Engine, because we're going to be doing that. And this is about as live of a demo you're ever going to see. So we're going to be flying by the seat of our pants, making it up as we go on some of the areas. It is a very early build of 5.5, so no promises. If it crashes, we're just going to start it back up and try again. And if it crashes twice, then we're just going to move on to the next thing. But I think it's going to work out. Hopefully it's going to work out. We're going to find out. So I've been at Epic for coming up on 7 years, a couple as a contractor, five as technical marketing. Prior to that, I was kind of traditional DCC. I did a lot of stuff with Maya, a lot of stuff with Motion Builder. I was at Autodesk prior for a very, very long time. And did some CAD stuff. So most of the things I was doing for Epic was enterprise related, and that sort of has grown into just the engine. As the engine's matured and the enterprise business has become very common with all the other parts of what Epic does, it's all kind of just blended together. So the presentation that we're going to be looking at today is kind of approaching it from the mindset of a DCC user, because that's kind of my background, but I will be showing some gameplay stuff and some of the things that we've been working on that. And these are just some of the things that I thought were kind of cool about the engine. It's not touching everything that's new. Like that would just, I don't have time to do that in an interactive demo. But it is covering some of the stuff that I really thought was pretty fun, and some of the things that were mentioned in the keynote you'll see in this presentation. A lot of what I'm showing is experimental. It's like labeled as experimental. Some of the stuff that I'm showing has just actually been moved into production ready or into beta. So there's kind of a variety of different levels of like where we're at in the level of completeness of the features that we're looking at. But all in all, the stuff's pretty awesome. And 5.5 is amazing. I don't know if you guys got to the keynote and got to see some of the content in that, but we're really excited about the things that are happening with the engine, and it just keeps moving forward. So what we're going to be looking at today is it's a little bit of rendering, a little bit of animation, some dynamics. I'm going to touch on Mutable really quickly and kind of just explain to you how that's set up and how we're using it actually at Epic. And that's going to hopefully take us through about 45 minutes. I'll have some time for Q&A at the end, unless I go really fast. I do tend to talk quick. New York, it just comes out, and I try to talk slow, but I get excited, and I get excited. So I talk fast. So I apologize if you're a non-native English speaker, because I do tend to get amped up. And I just drank a big coffee too, so now I'm really, I'm fighting the midday little lull there. So as I said, it's a live demo. A lot could go wrong, but a lot could go right. So let's see what happens here. So we'll jump over to the editor, and I'll give you a glimpse at what we're going to be playing around with. So this is a data set that I have been working on. Let's just get rid of that guy. For a little bit now, kind of as 5.5 sort of started coming online, I started figuring out what I wanted to show. I wanted to make a diner, like Route 66 vibe, and I like big mechs, so I'm like big mechs and cool vans and desert scenes. So I've been working on this for about 2 months off and on, and pretty intensely the last few days, honestly, trying to get it together for the show and get those renders out for the keynote. It's a bunch of stuff that's been kit bashed together. So there's a bunch of Quixel assets in here. There's stuff off of Fab or the marketplace in here. There's stuff I made in Maya. All the trees are Quixel. A lot of the rocks are Quixel, and a lot of the other assets are kind of coming from a variety of places. And I'll be kind of talking about those as we go. And the first thing that we're really going to be kind of thinking about or talking about is some of the improvements that we've made to rendering. And rendering has come a long way since UE5. We're continuing to make it both more performant, but also the visual fidelity continues to increase. Looming gets better, looming gets faster. And 5.5 has some really great new features, specifically around that. There's a new functionality called megalights. This scene is actually using megalights. We'll be going ahead and looking at that also. There's also the improvements to the way that we're threading. So we continue to work on that. We will continue to work on that. So the performance is much better. Hardware ray tracing is on by default. That's also new in 5.5. Both the render thread and the RHI thread have been parallelized now, so we're seeing really nice improvements in speed. And we've improved the efficiency of the CPU code for skeletal caches and things like that. And we'll be looking at that in conjunction with nanite skeletal meshes as we kind of look through this presentation. That robot's actually a nanite skeletal mesh, and we'll dig in and kind of talk about the impact that has on the ability for you to to work in a slightly different way, especially if you're doing nonlinear content, right? Like if you're going out to a mobile platform, chances are you're not going to be sending a 6 million polygon robot like I have in my scene to your phone. But I'm just trying to make really cool looking pictures that are fast and performant that I can burn out to make these movies with. So for me, throwing in that kind of film res asset and just not having to worry about it it's just great. It really, really accelerates the way I approach working in the editor and in the engine. So let's go ahead and let's just close this down really quickly. We'll go back out of animation mode, and we can just explore this scene a little bit. Actually, let's go ahead and just give that guy a kick, just so he doesn't shimmer like that. So what I've got going on in this environment, obviously, it's a relatively large world. It's using nanite, again, pretty much everywhere. So the terrain's a big nanite terrain. I've got this crazy windy little spline-based road that goes shooting down the mountain range, and it kind of goes off that direction. Really, really big, vast environment. And again, tons and tons of detail in this scene, primarily because I'm tapping into nanite meshes, right? So if we look at the nanite triangles in this, it's really heavy, right? Especially this robot. Like if I fly in on this robot, he started off as a fusion model. So he came out of a solids application. And if you look at something like some of these fillets, right? Like these little guys right here, all those little rounds and bevels and fillets and things like that, they're really, really densely tessellated. I brought it into Maya, did all the UV work inside of Maya, then went over to Substance Painter to do the texturing work, and then just brought them in and turned them into a control rig and got that really fun animation on them that was done by my friend Frederick, who kind of helped me out with that. So that's the basics of what's going on with that robot, and the fact that he is this nanite skeletal mesh makes him much more performant. Like he's much, much faster than he was before he got turned into that nanite skeletal mesh. And he just works really nicely with virtual shadow maps and all those things they all stack on top of each other and layer together to give you this end final result. The other thing that's worth noting is in this scene, we put a lot of work into removing noise in the environment, right? So we've got a really great new denoiser, right? And this has a huge impact on almost everything that you do, right? So in this environment, that's why kind of I went with the diner was like, all right, I had to show like rough reflections on metal. So I'm like, all right, cool, diners are metal. I'll make a rough reflective metal diner. And you can really get a sense of what those reflections are doing with that new denoiser. When you zoom in on areas like this, like prior to 5.5, that would have a lot of shimmer in it, right? Like that reflection would not look that refined and that tight. It wouldn't, even though it's a blurry reflection, it still wouldn't have that kind of that crispness to it that doesn't shimmer and do weird things. The other thing that's really interesting about this is because that denoiser is so good, I'm actually cranking up the min rough before the ray tracing kicks in a little bit higher. Like the default value is 0.4. If you're doing something, a game and you need every little ounce of performance, you might keep that down low. But if you're doing something and you've got the bandwidth or you're targeting like I built this on a 4090. It's actually running on a 4080 now. But I'm like, heck, I'm going to crank that roughness value up, and you get a little bit more out of it. Like visually, if you crank that roughness value up, and I've got enough bandwidth even on a 4080 in this scene that it's not that big of a deal. So if we were to just take a look at our post-process volume here, and let's just slide this guy over here. Like we'll grab this exterior post-process volume, and if we go down here and look at the lumen reflection. So I've got 2 bounces on, but you can see I've got that max trace rough set up to like 0.7, because look at what happens if I drop it down, down into the default range. If you look at, if you look at the metal around on the diner sign, the metal on these columns, and even this background mountain, which is again came off of the marketplace. Really, really great asset. That background landscape is really super cool. If anybody has questions about that afterwards, just come up and I can try to figure out which the name of the assets were that I used when I kit bashed this thing together. But if we go back into that post-process volume, which is, where did it go? I lost it. There's so many of them in here. That's the inside one. I'm looking for, hold on. I'm looking for the one that's lower. Oh, you know what, I'm going to do this. Here's a good trick. If you hold down the Shift key and you click on the arrow, it'll compress everything down. I don't know if you guys know that, but it's a good trick. So watch what happens as I start to increase this. You can start to see especially around that diner sign where all that stuff starts to kind of come together and these poles, they just start to look a little bit better. Another area that roughness really comes into play is something like these puddles, right? So on a puddle, the roughness value in the middle is really, really low. It's like almost 0, right? Really, really low. And then it goes out to the asphalt, which is pretty high, like 0.7. And you get this little blending transition effect. And prior to having that really awesome denoiser, that blend between there, you'd get this little band of halo of noise around your puddles and things like that. So the denoiser, it's just great. You guys can tell I'm excited about a denoiser. That's who I am. I'm excited about a denoiser. That's kind of sad, but that's where it is. Yeah, so a couple of other things that are kind of interesting on this guy. Like if you look at the paint, this is using a clear coat material. So as I kind of move across this, with the clear coat, you get like a really rough reflection on top, or a really smooth reflection on top, but then you have that broader kind of diffusive reflection. It's almost two speck loads happening stacked on top of each other. So yeah, it holds up on that screen. You can kind of get that sense of, it all sort of makes it all work and come together and give you these really nice noise-free results. And this is using UDIMs. Unreal does a great job with UDIMs now. So if you're coming from a traditional, DCC film pipeline, UDIMs are wonderful. That van has big AK textures all over it. I'm using all the texture memory that the 4080 has. Like, I'm using it all. I thought I was going to have a 4090, but I got a 4080, and it's fine. I just used my LOD bias to step a few of my textures down and get it into that memory footprint. So that's basically it for the improvements to Lumen. Ray tracing's on by default. Performance is better. And the scene actually, even though it doesn't look like it, is being lit with megalights, okay? So I've got 300-400 lights inside of this scene right now. It looks like it's lit by the sun, because it's pretty much being lit by the sun. But if we start to change that sun and drop that sun down, you'll start to get a sense of why I have megalights turned on. And sometimes when I use Control-L to move my sun in this scene, it works. And sometimes it grabs not the sunlight and it grabs a different light. So dynamically lit scenes are really great. They're fun. You can just wiggle the sun around and you get some cool stuff, right? So I've actually got a ton of lights. Like if we look at something like this, and again, as the light goes down, noise starts to increase. So that denoiser is actually working even a little bit harder now on this more dusky kind of light model that I have set up. And if we just hit the G key to bring up what's going on in our scene, where are all of those lights, you ask? Well, they're doing like I have a bunch of little tiny kicks floating around those neon lights. You fly in here, like each one of these little neon guys has a little area light. There's little neon tube lights that are getting extra kicks. You fly into the diner. Again, tons and tons of lights. Now you'll notice that as I'm moving from day to night, that the light values from my diner and my gas station, they all just kind of work, right? Like if I drop the sun down a little bit lower, just hit Control-L and let's get this to a full night scene. Did you see how like the light, even though when it was sunny, you could still see the light inside the diner, right? Like if we look at the diner now, it's still going to have light on, but it's not going to be overly blown out, right? And the reason that's happening is we've added and I don't even know if it's in the release notes or the docs. I just found it. There's a new parameter. There's actually 2 really cool new parameters on lights. Quality of life stuff. Like, this is the best thing about it on the Unreal Engine. There's developers that will just drop something in and you don't even know, and it just shows up one day and you're like, I didn't know I needed that in my life, but man, is that great. So what this new parameter that they added to lights let's just go in here and I'll just select one of these lights just so that we can look at it. Zip on into this diner. Need to grab a light. Let's grab, those icons are small. That's fun. All right, yeah, so if we look at this and we search for exposure, maybe that's not going to come up. Let's do it like this. Grab you. Yeah, so this inverse exposure blend is the new parameter, and that allows you to basically set a value so it looks at the overall luminance in your scene and adjusts as the sun goes down. It basically decreases the intensity of those lights inside the diner, and then when it goes up to the 50,000 LUTs that's on the sun that I have, when the sun's at the highest point, right, and it's up and it's just super bright sun, it just lifts the intensity of those lights so that that diner still stays lit. And the same thing's kind of happening, you know, in the little gas station, right? Like if we fly over and go explore my gas station, you know, inside of here, there's some interior lights, and these are using the same kind of the same idea, the same workflow to kind of keep that light balanced regardless of what's happening with the sun, which is pretty dope. And you know, like, I'm doing a lot of stuff. Like if you look at like these little lights here, like I have these guys kind of scattered around. These are like my landscape lighting model and my building lighting model. So I got these little LED, you know, pieces of geometry, and then on those I have a spotlight that's kind of coming out, and it's got a light profile on it. That's why it's got that funny little shape on there. That's giving me a visual representation of the IES light profile. But then I also put a little point light in there. So almost anywhere you see a light, I'm stacking kind of two together to give me that little bit of like extra bloom right around the light, and it lights the fixture also. So the same thing's happening on all the street lights. So every street light, if you look at all my street lights, they're all going to have, you know, scattered all the way down that street, these extra, you know, kind of little stacked lighting setup. So I don't know, I think that looks pretty cool. And then, you know, I've got like landscape lights because I want my trees to show up because I worked so hard to place all the trees. And then of course, you know, the van just looks pretty dope. And so the van, I had so much fun with this van. I like vans from the 70s and 80s, so I kind of got like a modern shaped van and then just ripped it apart and changed the wheel wells and squashed the nose down and did some fun stuff. And we'll look a little bit more about how you can deform vans later in the presentation. But yeah, the van was cool. I don't have a van. I have an old Land Rover. It's kind of like this. Van's cooler though. Anyway, let's keep moving forward. So we talked about lights. We talked about, oh, this is new. This is also very, very cool. There's a couple of other things that are going on in this scene. So if you look, I've got a moon, yay, and stars. That's using the new, what is it called? It's a new plugin. Let's go to plugins and search. I call it the wrong thing. It's Day Sequence, maybe. Oh, that's not a plugin, is it? Yeah, that is a plugin. Let's search for this guy. Yeah, Day Sequencer. So this is new in 5.5, and it's just a fancy material that comes with a timeline, but it lets you texture map the moon if you want. The moon itself gets positioned based off the light that's got, you know, the ID. When you make a sun-sky system in Unreal, you get to define your sunlight, and then the second light that you put the integer up one value to 1, that becomes your moonlight. So the position of that moon is tied to my second light that's in my scene. So I've got 2 directional lights in my scene, one for the sun, one for the moon. And as the sun moves, it will crescent the moon and do all the things you'd expect it to do with the moon. And then you can shove your own texture maps on the moon. There's different parameters there for the sun spot in the scene, so you can overdrive the sun spot, which is actually also being driven. So it's a sky environment sphere, like an inverse sphere that's got this fancy material on it, essentially, that just gives you stars. There's lots of controls for the stars. The stars can move. But yeah, so that's another new thing in 5.5 that I'm actually using in this scene. And then the final thing that I want to talk about for rendering is the new cloud master material. So it's still using the volumetric cloud material, same one that we had previously, but it's much easier to work with now. It's just, well, it has words that humans understand as opposed to like what the original one had. I mean, I still had fun with the old master material, but you know, I kind of came up with some clouds that looked good, and I just always use those over and over and over again because I just didn't want to try to ever do that again. But the new one is pedestrian. Anyone can pick it up and play with it. So let's just check it out. If we just search for cloud. Yeah, so here, let's check out this one just for fun. I'll bring it up an instance of it, right? So this is the legacy one with, you know, all these fun words that I can't pronounce or spell. Don't know what they mean, but you move the sliders around and you can make some clouds. It's okay, cool, great, whatever. But now we've got this new one, which is what is being displayed in our scene now, and you know, it's just so much more accessible. So I'll make this a little bit longer so you guys can kind of see what's going on with it. All right, so there is the cloud layout section, then there's the cloud shape. So if you go into this, there is, you know, really simple controls for how much coverage you have, right? Like it just grows a cloud. It's much easier than it did in the previous one. But then there's also the cloud type. So these are just, you can mix between all kinds of different levels and the different types of clouds that you have. And obviously there's stormy clouds. And then one of the other things that's really great is just a cloud density. So you can just kind of crank that up or crank that down, and it doesn't change the overall shape. It just gives you the ability to make them a little crisper or a little wispier or a little softer, a little more transparent just by adjusting that density. And then if you look in the storm section, there's controls for adding lightning and things like that. So it's just a much easier, more accessible master material that's still driving that same volumetric cloud material that we've had previously in Unreal. So that's also new in 5.5. So let me think. Did I talk about everything? We talked about nanite skeletal meshes. Oh, this is the craziest thing. Again, it's a really silly little thing, but if you look at this, and I think it's convert. Yeah, convert actor type. So you can convert the light from, if you've got a point light and you want it to be a directional light, or a spotlight you want it to be a directional light, you can convert your light type. So tiny little silly thing, but man, if you're a lighter, it makes a huge difference in your day. So we talked about the cloud master material. I'm not going to show it, but there is now the ability, and if you're a landscape artist or a level designer, we now have the ability to do geometry paint directly on nanite meshes. So it's like doing vertex paint on nanite meshes, but then it can transfer down onto LODs and non-nanite based meshes. So that allows you to work with nanite meshes, but then still get all that work that you do, like if you're doing any vertex painting, or it's called geometry painting now, and still get that off of the nanite stuff onto your standard low-res polygonal assets, onto your lower, mobile platforms and things like that. So I'm not demoing that, but it's just like it's like the same paint tools we had before, but nanite is now an option for you to use, and you're not like pigeonholed in as you were previously to 5.5. Last thing worth mentioning is Path Tracer's production ready, and we've added experimental new features to the Path Tracer also, and it now supports Vulkan on a Linux render farm. So actually, somebody was just asking me about that last night. So yeah, it's a little bit of love into the Path Tracer also. Okay, so that's it for rendering. I think that is it for rendering. Let's talk about the next slide, which is going to be. Ooh, we did that. Oh, this is cool. Some animation stuff. Okay, cool. So in animation, I got to get the sun back up though, because I like the sun. Let's make it bright. Woohoo! Yeah, perfect. Great lighting. It's coming in a different direction than it was prior, but it's still really cool. So animation tools continue to improve. There's been some nice additions to the modular control rig. That's great. There's been really nice stuff done with just the sequencer tool and the animation tools in general. So we now have a nice time warp functionality directly inside a sequencer, as well as the ability to do layered animation. So I'm going to try to show that, and hopefully it'll work. This is the area where we're kind of flying by the seat of our pants. So I've got this unfold animation on my character, right? Like, let's just expand that out and just kind of slide down here. So this should be the first clip. Yeah, okay, so there's my little robot animation. Woohoo! He's doing his thing, which is super fun and super cool. And what we want to do is I want to just change that foot animation, right? So right now, this is just a straight anim clip. So what I'm going to do is I'm going to go right-click on top of this. I'm going to go to Control Rig, and I'm going to do a layered control rig on this guy. So we're just going to say layered control rig, and it's this high-res one. So we'll add that on. So now we've got a control rig on here, which is great, whatever, cool. It's got all these controls. And I can start animating directly on this control rig, and it would be an additive thing, right? But that's how we had it in 5.4, and you still might do it in that way, but we've actually added animation layers now, which feel very similar to Maya's animation layers, which as a old school Maya guy, hey, that's good. That makes me happy. So how does it work? Well, basically, let's just go ahead and let's grab this guy's, let's hit G to get our control rig to show up. We'll grab his foot. So with that foot active, I'm going to go over here, and we're going to go to layers. So we've got this new layer window, and I'm just going to drag and drop it right over there, and I'm going to say make a new layer. So with that animation layer, on that foot highlighted, I'm just going to set like a bounding key. So I'm going to set like one there and then one there on both ends, and I'm just going to make that arc a little bit higher. So we'll just say, okay, left foot, cool. We'll keyframe that. We'll move forward in time. We'll drop that foot right as it plants. We'll keyframe that, and we can kind of zoom in here a little bit. Woohoo! And we'll just kind of go to the high point of that. We're going to crank that guy up, and we'll keyframe that one more time. So, we're just doing this pretty straightforward, a little tweak on top of that. But because it's done with animation layers, you can blend and add these on top of each other, right? So it feels just like Maya, honestly, and that's a good thing. It's a pretty good animation system. I think Unreal's getting better. I mean, you can just do so much in Unreal now, and the guys and the girls that are working on these tools are just, they're killing it. They're doing a great, great job. So animation layers, woohoo! You guys don't clap for anything. No lights, no animation layers. I mean, good grief. Looks like Maya. I mean, come on. This is good. This is good stuff. Anyway, so we got that robot doing his little thing. Let's talk about deforming the van. All right, so this is fun. I'm gonna. Do I have it in here? I don't think this is a skeletal mesh one. I think that's just a static mesh. All right, I'm gonna drop another van in my scene. Let's go. Let's find this guy. Van. Geometry collection. Yeah, skeletal mesh van off-road with class. Okay, cool. Here's a van. Yay. So it's a skeletal mesh. So what we're going to do is we're going to go and we're going to do, I want to deform this van and just make like a little weird transition effect happen. Like I was going to do a paint move across it and have it change material or something. I want to have like some weird geometry, wiggly effect. I'm going to do that with a lattice deformer. So this is new. Single click, add deformers into your sequencer. Really, really powerful feature. So with that van in our world, let's not focus on that. We'll just grab this guy. Oh, come on. So many things in this scene. This scene is gigantic, by the way. It's just so much stuff. It's crazy. I got to find this van. Where are you, dude? Okay, there you are. Cool. Here, I'm going to just wiggle this up, and we're going to drop this guy in here. Boop, just like that. So on the van, you have to. This is a plugin. It's like called Kit Animation or something like that. You have to load the plugin for the deformers to show up, but know that going into it. So then, and you also have to have engine content and plugin content visible in like the little content browser thingy, or else you won't find the deformers, which can throw you. So just look out for that. So we're going to say on this guy, we want to add a control rig, and instead of being a layered control rig and filtered by assets, I'm going to filter out just deformers, and I can search for lat. Oop. I told you I couldn't spell. I wasn't lying. I'm just going to put this 4x4 lattice on it. That's fine. You can do it. You hit G. Come on. Oh, don't die on me. Please don't die. Okay, there it is. All right, I got a lattice. Yay. And then if you look at the lattice, there's a bunch of controls. So I'm just going to go to the global control for that lattice. And right now, the lattice isn't doing anything, right? Like it's just chilling out there in the scene. So I'm going to scale it up really big, like that, and I'll scale it like that. And then I'm just going to drop that guy down on top of my van. And then I'm going to grab a point, and I'm just going to like do that. Like, look, yay! So that's like, this is also several million polygon model, right? Like that's a big old model. And the cool thing about this is, like I said, if you wanted to do like a wiggly transition effect, you can kind of punk it out a little bit, like grab some of these points and just do something like that. And then you can take the lattice back here at the global level and then just wipe it through it. I got to zoom out a little bit further so you can see that effect. But if you're trying to do like a little animated transition, like trippy thing, you just swipe that lattice with those deformation points on it across your object, and boom, just like that, you got a cool transition effect. We'll take questions at the end. I'll talk faster so that we have time for questions at the end. All right. So UX improvements. Oh, there's a new skin transfer algorithm. That's kind of fun. Layered animation, and then the deformers. Control rig stuff. Chase is doing a really great talk on control rig. So if you guys are interested in control rig, they added a lot more really polish to it, many more presets. Control rig, by the way, is all modularly built, right? So the original ones that we shipped it with, you could have added your own control modules to it all along, but we've added several more, simple reverse legs and orientation constraints and things like that have been added to control rig. So make sure you check out Chase's presentation if you want to learn more about control rig. So we're going to keep moving forward here, and I'm going to go to talk about choosers. All right, so choosers. Did everybody download the motion warping sample content that we just came out with after 5.4 came out, that library of all that motion capture data and the system that allows you to blend and do all the really great transition effects? And that's cool. It's really powerful. And it works on choosers, right? Choosers are part of the way that system works. Choosers are production ready now in 5.5, and they've had a lot of really nice little enhancements and improvements made to them. And I'm gonna show some of that to you right now. So let's go ahead and we can just blow this away. And hopefully my robot didn't get all shimmery. Yeah, that's good. Sometimes he gets all weird looking after you close down the sequencer and he's been animated with it, but he's looking good because I like my robots to look good. Anyway, so I've got this back here. I got this little girl. She started as a metahuman that I then brought into Maya and then shrunk wrap all these clothes on her and then skinned them up and then brought her back. And so she's like, she actually gets to control the mech warriors. Like she has a VR headset and she remote controls them with like a big glove. I have this whole story. I didn't finish it, but I have it in my mind, like it's there. Like I could do this story and someday it's gonna happen. Maybe on the demo pods, I'll have some time this week and I'll finish my story. Anyway, what I did is I just went into the example content and grabbed one of the chooser examples that ships with 5.5 and dropped it in my scene. And we're going to switch our game mode really quickly. Or actually, it might already be set. Let's see. Oh, I'm already set. Cool. So let's go ahead and hit play. Hopefully it works. You never know. Could play. Hey, it worked. Ooh, I'm over memory. Uh-oh. Well, that's okay. I don't mind. Shh, don't tell anyone. It's okay. It's a little stuttery because of that. Anyway, if I get close here, eventually she's going to start moving, okay? So what I did is I just walked into a trigger box. And what that trigger box does is it starts letting me use these sliders, and the sliders are ultimately driving the chooser. So if I move it to one side, she's going to get hit to that way. If I increase the intensity of the move, this is just randomly changing what clips she's going to grab. So if I move this to the center, she's going to move straight forward and back, and then this is right, and then if it's 180, it goes to 360, so then she'll start going forward again. And then there's a Boolean switch. So if I pull this is all just underneath it, driving a chooser, right? So now she's doing these different clips based off of the random things that it could pick that are inside of that chooser, and as I move the slider here, she'll start going to that side. And if I move this one, she'll start going to that side. So what is that doing underneath it all? Well, let's go ahead and pull up a chooser, and I'm going to just see if we can do something like. So this is the problem. I designed it on a bigger video card. I'm bringing my own card with me next year. I'm going to bring my own card with me. I'm done with this 4080. I want my 4090 back. Anyway, let's go ahead and I think if I was smart, I dropped these things in these little. You guys use these collections? Or favorites? Anyone using that stuff? Yeah, that's good. They're new to me. I haven't used them a lot. So if we look at this, we'll open the base chooser. So what happens is this is a chooser window, right? So the first base chooser basically goes through and it's going to choose between two other choosers. So it's going to go out and use a separate chooser for the die sequence and then a different chooser for the main hit sequences that we were playing with. So there's two choosers that this chooser sends stuff to. Now, new in 5.5, this is a sort of a legacy workflow, or not legacy, it's just a different way of doing it. But you can now do nested choosers directly in the UI. So that's a new feature in 5.5. You don't have to have separate choosers sitting in the content browser. You could actually do them all in one window with nested choosers if you choose to. That's kind of funny. So some other things that are also interesting and new is a lot of the operations and things like that, there's more choices. There's now also a randomized choice, so you can use that to really kind of bring a lot of life and variety into what the chooser's doing. So several different things have been added into that. So what we're going to do is we're going to actually close this one down, and we're going to bring up reaction death. Actually, I think the other one might have more stuff going on. Let's see. Yeah, all right, so this one's got a little more going on. So, yeah, like I said, there is new enums in it and things like that, so you can use that to add more logic and things like that. But we've also added, and this is really great, I'm going to minimize this down a little bit so that hopefully I can have both windows up at the same time while this is going. We have a debugger, right? So if I turn the debugger on, in theory, if I hit play here, it should actually show me what's going on. Hopefully it's going to work. I might have to select it in a slightly different way here. I don't think I got it. Oh yeah, I got it, cool. So as I'm doing this now, it's actually giving me the visual representation of what clips and what things are actually getting triggered and actually happening. So you can see those colors are changing, and the choices that choosers are making, I'm actually getting to visualize as I move through this with the debugger, which is really pretty awesome and very, very, very powerful feature. So, you know, certain things get blocked out where they're no longer a valid option, so they're not even visible, right? So it's giving me this nice debugging ability directly inside of the chooser. It's also worth mentioning that, you know, we're using choosers in a lot of our own IP, right? Like we're using it really heavily in our own internal IP. So they're battle tested. And the crazy thing about choosers, and a lot of people don't even realize this, is, well, as I said, the enum list has gone much larger than it was prior. But it doesn't have to be just tied to animation data, right? You could use the chooser to choose anything. You could trigger audio with it. It's literally anything that's available to you in Unreal, you can use the chooser to then kind of make driving choices to it. So it's a really powerful feature. Don't think of it just for blending animation clips, I guess is the takeaway that I'm trying to make there. Yeah, and the random feature is actually really pretty awesome. It's deeply integrated with blueprints. Works really great with motion matching. It's a very, very powerful tool. And lots of fit and finish in 5.5 for that. So the next thing that we're going to talk about, now that we've done choosers, I think is, I'm not sure, maybe mutable? Let's see. Yeah, it's mutable. OK. So this was in the keynote a little bit too, just for a second. I don't know if you guys saw that, but mutable is, again, a tool that we use a lot, like the minifigs are like just massive mutable thing, right? A really, really powerful tool for if you need to make a lot of assets, right, that are highly customizable with a lot of variants, like thousands and thousands of variants. Mutable is an amazingly powerful tool for doing that allows you to do it in a very visual way. And it can work with data tables, right? So the idea is you can build up a graph, and let me just pull it up. I'll bring up my mutable girl. Ooh, the microphone. All right, so here's that same survivor girl. And when I was setting this up in Maya, what I did is I made it extremely modular. Like the helmet's made up of a whole bunch of different parts. All of our different layered outfits are made up of a variety of parts. And mutable not only allows you to build a logic around how you're going to make all these different configurations, it also has a whole section that allows it to be optimized, right? So it's thinking about how to get the lightest weight asset onto the platform. So it can combine texture maps. It can blow away geometry in areas that you don't see it when you don't need it. And you're not manually doing all that. The idea is you're going to build a smart system that then is adaptable to the data sets that you ingest into it. So something like this graph is pretty representational. Like I was talking to the developers of the guys and girls who worked on Mutable, and they were saying like this level of graph is not terribly dissimilar from what a minifig is. And essentially, you build a high-level graph, and then for the Lego stuff, they're feeding a data table into it that then has literally thousands of variants. But the high-level logic kind of sits at this graph, and that's basically what we've got going on here. Is each one of these little sections is taking part of the character. So like the helmet comes in, and then even though it's a single mesh asset, Mutable knows all the different parts of that helmet. It provides it to you in a graph way that you can then essentially wire it together to build a simple little machine that lets you get an incredible amount of combinations set up. So essentially, the skeletal mesh comes in, you separate out all the different parts from the skeletal mesh, they get shoved into, in my character, we have it set up where there is a head, right? There's a body, and then there's the clothing. So the clothing is going to be everything that's not basically the underlying skinned mesh of the character. So the helmet, the cloth, the pants, the gloves, all that stuff for this little survivor girl is done through the clothing. So that's really kind of the logic is, there's the helmet, there's the head, then there's clipping meshes, which we're going to talk about in just a second. And the clipping meshes are just really simple little volumes that you make that allow you to say, when I put the jacket on, I don't need to carry all those polygons around that are underneath that jacket anymore, or they might even be passing through. Like that's the big thing is like, you don't want to have to manually make 1,000 versions of that jacket that fit every character. You want to make one version of that jacket and then clip out the stuff or shrink wrap that jacket into areas and do some simple morphing of that jacket to make it fit all the different variants that you have. And that's what this tool gives you the ability to do. So if we kind of look on the right-hand side on the instances, you can see these are all some of the switches. And all this is really doing is taking the logic that's in this graph, and these are the parameters that are exposed. So I've got the ability to turn on and off the backpack. I've got something like her gloves. Like the feet clipping plane, that's going to be like if we turned off, let's go down here, and let's turn off the boots so you can kind of see what's going on. So we put the boots to none. She's got feet under there, but if we look, you can see that there's actually a clipping volume that's been set up for the feet. So I can come down here and I could say, you know what, let's clip those feet away. I don't need those feet if I put the boots on. So you kind of build this logic into it with those graphs and with those nodes to give you a very configurable set of characters in your scene. And it doesn't have to just be characters, right? It can be anything in Unreal again. It could be vehicles, it could be weapons, it could be anything. So mutable, super, super powerful tool if you've got a massive amount of data that you need to corral into something that's a bit more manageable. So hopefully that makes sense. It's a really fun tool. And then of course, I got to put on her other. She needs her gun, and she needs her upper body clipped out, and I'm going to put a jacket on her. Got the shirts, let's get the boots back on, and then the jacket, which I had fun with the jacket. So you can see the jacket is clipping, right? So that shirt's kind of going through it. So what we'd want to do is we want to basically clip out the lower body and then clip out the upper body. I don't know where the clipping for the upper body is. It's got to be buried in here somewhere. I bet it's under here. We expand the jacket out. Yeah, there it is. So boop, turn the shirt clip on. It just knocks it out, basically, like just blows those polygons away. So that's mutable. And again, this is being heavily used in our internal projects. So it's pretty battle tested at this point. All right, I got to keep moving or else I won't have time for QA. We did talk about mutable, which is fun. And then, dynamics, yay. All right, so this is kind of cool. Let's get rid of that. And so we've got a new modular car rig, a vehicle rig, I should say. It's not even just cars, because it can be cars or planes or hovercraft or whatever you want, done with chaos. So if we were to switch our level over, I'm just going to show you one that's pre-done. So if we go in here to four-wheel vehicle, modular four-wheel, okay, I think that's probably good. And let's kind of frame ourselves up here and hit play. So I just switched my game mode. Hopefully it works. Should load up a little. Yeah, it does. Cool. This is it comes with the sample content. So this little buggy is part of the sample content. We're going to drive it around for a second. Then I'm going to break it down and show you how it's built. And then we're going to add in a van. Instead of having a little buggy, we're going to use my van. And it can work with in a couple different ways. So you can see as I drive this guy around, I'm a bad driver, but whatever. Oh, goodness gracious. Let's back up. I really want to go jump something, so I'm going off-road in here in a second. I just need to find my entry point. Oh, come on. Yeah, here we go. Oh, man. So chaos physics, and the setup's ridiculously easy. That's the really fun thing about this. So let's get out of that, and let's expand this out, and we'll look at how that vehicle's set up, and then I'll walk you through doing a few other things with it. So if we go down in here and we look at, do I have it set? No, I don't. Ban overload. All right. Well, here. We'll look at this one. All right. So first things first. inside of here is the buggy. The way the buggy is set up is really simple little sim modules. So essentially, you take a body. On the body, you have to add a chassis, you add an engine, a clutch, and a transmission. These are all just added to something by saying sim, and then you can add in, a wing or a wheel or a thruster, right? So they're modular components that you add on to geometry collections. So geometry collections, for those of you who haven't used them, let you take meshes and then turn them into a collection that the physics engine understands. And it can actually take those static meshes and know where all the subcomponents of those static meshes are and do things with them, which we'll look at in just a second when we blow up a sign. But essentially, that's what's going on with this car is it's got a wheel, then hanging off of that collection for the wheel, we've got a suspension, and then we've got the actual physics wheel underneath it. And that's all you have to do. So if I wanted to add and make this a 6-wheel vehicle, I could literally take this wheel and this suspension and that and duplicate it. Or if I wanted to, I'm just going to move this off the screen really fast, and I'm going to get in here, and I'm going to actually pull up the engine content. Let's see here. Let's close you down. Is the engine content not shown? It's got to be shown. I'm sure it's shown. Let's get rid of that. Oh, no, maybe it's not. Settings, engine content, and settings, plugin content. OK, cool. So in the engine, this is a plugin that you need to load for both of these to show up. If you go into plugins and you go down here into, oh, that's why it wasn't showing up. I did have it dragged into that thing. It's engine content plugins. There's a thing called Chaos Modular Vehicle Examples, right? So if you look at the different vehicles that it has inside of here, it's got planes, it's got hovercraft, it's got 6-wheel cars, but it also has blueprint classes of these wheels. So what I'm going to do is, what the blueprint class does, oops, sorry about that, guys. What the blueprint class does is it's basically just got the suspension and stuff in it directly, right? Like it's just a little faster to add it. So what I'm going to do is I'm going to drag and drop this blueprint wheel into my scene. And did I do it? Maybe? I can't see if I did or not. You see a wheel blueprint? I may not have done it. I thought I could drag and drop it in. Maybe I have to drag and drop it in here. Let's put it underneath that guy. OK, there we go. Where'd you go? It's under, oh, wheel. I did it twice. OK. Well, I needed 2 wheels anyway, because I want to make a 6-wheeled vehicle. So, woohoo! Look, I'm building a car with 6 wheels, and like, it's easy. Like, crazy. OK, cool. Compile. And what is this one called anyway? I'm not sure what this vehicle's called. Got to make sure I have the right pawn selected when we go back. I think I'm back. Where was I with that guy? I go into, I don't remember where I was working out of. You guys remember where I was working out of? Van, probably, right? Like I like my van, so I'm probably in there. Oh, there it is. Yay. OK. Oh, cool. I put my initials on it. I was trying to make it easy for myself, but. So I'm going to search for my initials. Check it out. There he is. OK, cool. Now, let's, think it's going to work? I think it's going to work, too. What are we going to say? Let's see if we got a 6-wheel car. Vehicle. Yeah. Dope. Yay. Now, it can also work with skeletal meshes. Now, this is the area where it might crash, because it has crashed a few times for me for this. So what we're going to do, oh boy, I'm getting nuts. What we're going to do is we're going to, instead of using just a modular rig, I've got this one setup that's essentially it's the same thing. You build the system with the wheels and the transmission, the engine, the chassis, but I'm having a skeletal mesh that gets dragged along for the ride, right? And it ships with, in that plugin directory, there's a sports car set up with the skeletal mesh. So I set my truck up with the skeletal mesh just to show the variety of it. So we'll say skeletal modular vehicle game mode, and then in that guy, we'll search for van, and we want to get our van skeletal mesh modular vehicle thingy, and we'll kind of pull over. I got an army of vans. Look at this. I'm going to have 3 of them now. All right, so we're gonna hit play on this. Hopefully, fingers crossed, things are good to us. Yay! And then check it out. I can drive my little van around. Let's go chill by our diner. This is a single skeletal mesh, but you could do like a blueprint mesh or something like that. You could stack. It goes along for the ride. So whatever you parent below the main vehicle chassis node is just going to get carried along for the ride. But this has it knows to drive the wheels and things like that. I just copied the skeleton that was on the sports car and then rigged my van into, I moved the positions of where those bones were and then just rigged my van directly into the sports car one, mainly because I was, trying to build a demo really fast. So I'm stealing everything I can to do it. All right, so that's that. All right, so we're going to open another scene. Well, it's kind of the same scene, but it's in here. I'm going to show you. We can do it, actually, we'll start here first. All right, so geometry collections I mentioned before, right? So that you take a static mesh, you bring it into your scene, you go into the fracture button and you say create a geometry collection from it, and it goes through and figures some stuff out where all the islands are and makes a geometry collection of nodes. We now have a really nice node-based dynamic system inside of Unreal for doing fracturing and things like that. So it's very, it's kind of like Houdini. If anybody here uses Houdini, it's got some similar concepts. We're doing it slightly differently because we're like a game engine, and that's Houdini. It's like Houdini. So, but we're doing some cool stuff, and I think that you guys will like this. So, this is about as simple as it gets right now. Hopefully, it's going to open and not crash because that's taking some time. Okay. So what we've got is we've got our sim view on the right, and then we've got this little view on the left here of what we're starting with. So there's our dynamic sign, right? So that dynamic sign that's a single static mesh, that sign, right? It's turned into a geometry collection. So the geometry collection can figure out where all the little different parts are, right? That's what the geometry collection's doing. There's an option to separate it out, essentially. It's a checkbox. So that's going through, and then if we zoom in on this, and you'll notice that there's 218 elements in that sign. That 218 spots, right? It has to be, and the geometry needs to be watertight. Keep that in mind, because if it's not watertight, the physics engine isn't going to work with it, or the fracturing isn't going to work with it. So what we're doing is we're taking the sign, we're finding the volume of it, just making a bounding box, and inside that bounding box, we're going to scatter points, and then we're going to do a Voronoi fracture based on those points inside of that box. That's all we're really doing. Really, really straightforward. So it comes through, it uniformly scatters points. We're going to put this really low just for this demo to show you. Come on, it's a little slow. So not a lot of points in there. We run it through the fracture. The fracture also has lots of details and lots of control, and then it outputs it. So what that means is if we hit this and we hit play, it drops, it does its little thing, it breaks apart, right? There's a little bit of fracturing happening there, but mainly it's those 218 elements that are kind of dropping down. This is where the magic is, because it's a non-destructive procedural workflow, right? This is really, it's pretty awesome, actually. For anybody who's done any kind of destruction workflows in the past, this is going to make you happy. So let's just put this up to 300. I don't know, we'll put the minimum points to something like 20. So do you remember what it looked like the first time? It was pretty cool effect, but it wasn't broken down into lots of little pieces. So now that we've added more points inside of that volume, that bounding box when we sim it, lots more fracturing, right? Awesome. Now, keep in mind, if you wanted to, you can go and you can cache this. So you can cache it, scrub it, play it back and forth, do all kinds of fun stuff with it, right? So that's pretty cool. Now, let's look at a slightly more complex example. So let's just, we'll close this one down, and I'll just grab this one, and I'll walk you through I'm running out of time. Oh my gosh, I've got 2 minutes. Anyway, the Q&A didn't happen. You guys are gonna have to come see me downstairs. I'm on those demo kiosk pods all week, so come hang out with me and we can talk about stuff. So this one is essentially very similar. We're going through, the first thing we're doing is we're pruning out some points. So see, it's 218 elements right here. We prune that down to get it to a slightly lower count. We're getting rid of the bad stuff, basically, right, with that little pruning operation. And then we're doing the same bounding box idea, but this time we're finding the bottom half and the top half. So we make a bounding box, but then we modify that bounding box so that we're essentially chopping it into two pieces. So we have a top box and a bottom box so that I can get different fracture. I'm running two different fractures. That's all this is. It's just a little bit of logic to run. The top path does the top part of the box. It has its own fracture settings. Then the bottom flow of the graph is the bottom part of the, that's the rods and all that other stuff that's on the bottom. It's got its own settings. There is an explode node, which is kind of funny. Again, very similar to some other applications, but if you were in the right click, this is fun. So the enable disable state in this build isn't working, so that makes life fun. That took me a little bit of time to figure out, but I think if I just come down here and hopefully if I click this button, yeah, it does, look, yay, it explodes it. Anybody who's done physics work in other applications, that'll be pretty familiar with. So anyway, we do that, we hit play. I'm gonna run over by 2 minutes and people are gonna hate me, the next speakers. We have another fracture thing. So the final thing I wanna show you guys is this in context with a vehicle, and I'm gonna do that with another level that we're just gonna open up because it'll be faster, and we don't wanna save that. So now we've got a car, there's gonna be stuff, ooh, it crashed. I'm gonna restart and show you my car smashing the sign even though I'm a minute over. There's a visual debugger now too. It's very much like the rewind debugger for animation. I don't have time to show that because we ran out of time, but it lets you put 2 windows up, record the state, see everything that's happening with the physics and traces and sweep traces and things like that. It's very, very cool. Hopefully this is gonna open quickly and we'll drive the car around. Okay, go in here. Basic level. Yay, okay, cool. This one's fast, by the way, because it's like, there's nothing in it. But, oh, here, I talked about it. I'm going to show it. People hate me. I don't care. Build, tools, all, debug. Visual debugger. Chaos, visual debugger. Yeah, okay. Oh, dock, please dock. Do you like a docky thing? Not on that window. Okay, this is not, it's not helping me. It's not helping me. All right, so check it out, record live session. That sounds powerful. Let's start up a thing and let's do this. I didn't turn any of the options on, so I'm not gonna query a ton of stuff, but that's running, that's recording. I'm driving around. I'm gonna smash some stuff because I like to smash into signs. And then let's find another one to smash. And then, of course, I've got this debugger that was recording all that stuff, so I can go back and then scrub through it and turn on different types of things to evaluate all kinds of different stuff. So that's it. That's Unreal 5.5. I'm a little over. I'm sorry. No time for Q&A, but I'm on those demo pods all day. Thanks, everybody, for your time. I really appreciate it, and enjoy Unreal Fest.
Afternoon, everybody.
Check, check.
Hey, my name is Casey Pike. I was the lead visualization supervisor on Kingdom of the Planet of the Apes. Over here is a man who I'm sure you all know. This is Wes Ball, the director.
Thanks for coming.
And this is Wesley, Krieger.
That's a good name. That's a good name.
If they say Wes, they're talking about him.
And he was our virtual art department lead for the visualization side. So Wes, can you talk a little bit about how you got started on Apes specifically, and when you kind of reached out to us?
Yeah. It's like if anyone was there today, early this morning, like I was describing how the mouse guard kind of thing was really got me started on Unreal, but also got me started with Casey here, because he was really the lead on all the animation. It was a small team. It was like 5 or 6 people or something.
Something like that, yeah.
So that, I kind of pestered, Casey, for a year and a half or so while we were building that whole thing. And what I even showed there was just the demo that we did for that 8-week period just to get greenlit. And then we built every set. We started animating the movie. We had like 10 minutes of the movie done. We worked a lot on that thing. And then when it crashed and burned, and it was pretty quick because I put out that little demo. I kind of slipped it out there. I followed Tim Miller's thing with Deadpool. And I kind of got slapped on the wrist a little bit, and they said, don't do that again, but let's talk about what's next, and that's when they said, what about Planet of the Apes, because Matt Reeves was a producer on Mouse Guard, so I got to know Matt, fairly well during the Mouse Guard experience, and then just, working with Weta, I had made 2.5 movies with them previously, and so I was learning the mocap thing, so it kind of felt like the perfect fit for them, and so the question was like, what do you do? Because there was no idea. There was just they want to do another one, So I actually, for a second there, I turned it down. I said, no thanks. I'm not sure how you follow those last 3 movies, and I wasn't really interested in doing a part 4, and then I had this idea of like doing this big giant time cut, if you've seen the movie, and how you kind of can sort of, stand on the foundation of the previous 3 movies, but kind of start something new, which is really important to the studio. They wanted something a little bit, let's just say a little less dark, They wanted something that's a little bit more adventurous, so we chose kind of a younger character and this kind of coming of age adventure thing, while still kind of fitting in with the, the 9+ I guess movies and TV shows that came before us, So that's kind of how this whole crazy adventure started, and that was, I tell people that was 5 years ago, a little over 5 years ago when I was asked that question, what would you do next, Planet of the Apes? That's the journey here.
Awesome. And then there was a certain point where you came to me for doing kind of a pitch viz to try to get a green light.
That's right. Yeah. So I don't remember when that was exactly when we did that.
Yeah. I mean, it was definitely
early.
It was early.
Yeah.
Yeah.
Because I had started playing Unreal already.
Yeah. You'd made your shot. That you showed
the
this
opening.
Morning. Yeah.
And a few little things here and there. But yeah, I don't know. I just like, let's go back to Casey and let's see what we can come up with.
Yeah. So what we did, Wes came to us with the idea of the opening climb in the movie.
Yeah.
And there was a lot of kind of thought about like how to stage the opening climb and what the mood of the opening climb was. And we had some design work, but really early design work. And we knew like the beats.
Yeah,
like,
kind of rough storyboards by Dan Milligan.
Yeah, and so then we ended up building like an environment that you can see there. That's part of it. But like the decrepit city covered in vines, and there was a lot of discussion about like how much vine versus concrete versus steel, and a lot of that.
That was important to me because like visually, granted we're not too worried about that in the previous stage, but like you want to convey that idea that it was a lost world. That to me was a really exciting idea. Is that when you first saw them, you almost didn't realize you're looking at buildings. It almost felt like, like mountains. That's the way that the apes kind of saw them, That was really important, and how we can use that to our advantage to make something kind of exciting and interesting with the way things were kind of crumbling and, all that kind of stuff, so.
Cool. Wesley, can you talk about some of the asset work that you put into this?
Yeah, getting into the pitch, Wes came to us with, I think it was Unreal 5.0.
Yeah. We got to jump.
Probably, yeah.
I need Lumen.
And he said, I want to do this in Unreal 5, and we None of our tools were in Unreal 5.
I think it was like alpha still or something.
Yeah,
wasn't
truly
it?
like alpha or beta. And, so our dev team was very nervous, and we were all like, I don't know if we can make this switch, but we made the shift, and then I think we even versioned up to, a little more stable of a build through production. But came to us with that first shot that he showed at the opening session with the eagle flying over the kind of the ruined city, and we took it from there into the climb. And so from the very beginning, we knew we were going to have to get into building a bunch of apes and a lot of these really grand environments. And so one thing that we like to touch on is in building the apes, like getting into all the groom systems that Unreal offers. And our groom artists had a lot lot making
that was a big deal because when we were doing Mascot, we couldn't do fur.
We couldn't do, well, we
sort of
did, we kind of had like an earlier version. I don't remember what like plugin it was. Yeah, but for this one, it was full grooms.
Full strands.
Yep.
With control over color and all the way it goes wild. And we even had a wet orangutan at some point, so you needed the dripping fur. And
awesome.
Yeah, got really deep into it.
Cool. So we're gonna show you guys a previs reel for the work, and you'll see some of that hair and a bunch of other work.
By the way, there is, for anyone who cares, on the HD DVD, there's this awesome little visual effects kind of top and bottom thing that we do. The whole movie, you watch it. Top is the final shot, I think, and the bottom is pure raw mocap, like the raw dailies, which is for people who are kind of interested in this stuff. It's a fantastic way to watch the movie to see what the work actually was that went into it.
Awesome.
Hopefully, it'll kind of like leak out there or something, and people can see it and talk about it. Not me this time.
Cool, so I wanted to talk a little bit about visualization, previs and postvis. So what you saw there was previs. A lot of the stuff that you guys have been seeing, so far today is final pixel stuff. It just looks absolutely amazing, and we love to try to push it as far as we can in a previs timeline. But what previs is fast prototyping, like rapid prototyping.
Yeah. By the time you really got dug into it, I'm like out on location scouts all day, and I'm not really, you guys are just racing, trying to catch up to us.
Yeah. So they would send us set scouts. They would scan, sets and environments, send that to us, and we would put animation in. And it's a very iterative, very creative process.
Very fluid.
Yeah. A lot of changes, a lot of just like 90-degree turns. But Wes, being an Unreal user himself, would jump into the engine, change things, make shots, send them to us to render or to add animation to.
And my ability to do that gets less and less as prep goes on. In the beginning, I'm going to work on this light, I'm going to make this little feather float, and at the end, I don't care, just put something in there, go. It's just really kind of rapid pace. But what's really tricky about this movie in particular, because the technical requirements are just, they're insane. It's not like a typical movie because of the requirements of, every set that we chose. We also have to think about where the IR cameras are going to go to do the mocap. So I mean, if I have, okay, I'm going to be roughly in this spot of this location. We're going to put a little camera there and hide it in the tree over there and hide over there. And now if I go up on the day and I decided, oh wait, I kind of want to go over there. That's 2 hours or whatever it is time for him to go change all those cameras. You know what I mean? So the visualization side of things was really, a chance for us to kind of see, is this going to work? Are we making the right choices?
Cool. In a lot of the stuff that you just saw, you saw that there was, like, some of the motion was pretty rough, a lot of kind of just like, that kind of stuff, but some of it was mocap, and that's part of the visualization process, is you only have like so much time. You need to convey the idea of the shots and the edit so that, Wes and others.
Yeah, and something else you saw, I'm a big fan of, I like to do treat previs like a shoot, where give me lots of shots, give me lots of cameras, because then I'll go in the editing room and start finding ways to put it together. You know what I mean? Personally, that's the way I kind of like to work, because I get ideas along the way, like, oh, I can cut to this, and then sometimes I'll give you back a cut, and that shot wasn't supposed to go there, but it gives you an idea of what I'm thinking the rhythm needs to be, because I'm big on like flow, shot flow, and if you watch the, even starting with Ruin, there's a real kind of organic kind of flow, where I try to edit in camera and not like just kind of, manufacture it, completely in the edit. You know what I mean?
Yeah, and that reminds me of for the Marauder attack, which you saw in the previous reel there. It's at night. There's a bunch of fire and stuff. That started off being Wes having storyboarded it, but like kind of coming to us about these, we want to hit these beats, but these aren't necessarily the shots.
Yeah.
You know, and so there was a lot of ideas of like, oh, well, what if some horses ran by like a building and like caught it on fire, and how does that meet up with the next beat? And then we all want to do it as a oneer.
Yeah, exactly. That was the little oops thing, you know. It was like we planned on this whole little, you know, thing, and then we were out on this location and figuring this out. And it's like, you know what, this would be badass if we just did it in one unbroken shot for like a minute and a half. The truth is, we ended up actually cutting 30 seconds out, which was a bitch to deal with because we had to reseam the shots, you know. But it was a cool experience to kind of like, you know, build that thing, and you guys could help us with that and like figure out what are the moments, what are the beats, you know.
Yeah.
It was key. But as soon as you've seen the movie, you can see how that was done, and of course it was going to be at dusk, you know, so that meant we had basically a 15-minute window to shoot this sequence, the entire basically oneer. So, you know, the previs was crucial, I think, you know, to make sure we had our ducks in a row there.
And one of the ways that Unreal Engine was really helpful in that was that the cinematographer, Jula, he got into Unreal.
Yeah, so I said, Jula, you better learn this thing. And he got into it, and he loved it. That's kind of the beauty of the engine. Once you do get your head around how it works, anyone can kind of pick it up and start playing. If you have just a little bit of knowledge about it, you can have a lot of fun, and it just makes it so much more efficient. When my art team's working on it, you guys are working on it, Jula's on it, and I'm on it. It's like it's a great experience.
Yeah, so Jula, we had all these different like beats animated, and we had kind of our own camera path, like kind of laid out to hit all these beats. And we go to show Wes, and in the same meeting, Jula shows up with his previs. I'm like, what? And so
and it was kind of an amalgam by the end. It was kind of an amalgam of the two. Yeah.
It was. We were able, because he wasn't working in Unreal, just migrate his stuff over, grab his camera, adjust it to. He was prevising on a like a environment that was like kind of close to
it was like some marketplace environment.
Right, and so we kind of used his camera, used all the beats, added in, you know, what beats we had come up with that Wes was like, no, we got to get that in there. And yeah, it was like this really collaborative process to get that.
And it's so important because what people don't realize is that I shoot this movie twice. I shoot the movie first with the actors and all in their mocap gear, and then I say, okay, you know, on the day, you know, I'll sit there and, okay, I think while the clock's running, you know, and the light's going away, you know, I say, I think it's gonna be take 3. And so that means my camera operator, Jula, as well, myself, all the stunt guys, all the actors, we have to go in and look at the timing. Okay, at 15 seconds in, we pan right, and then at 30 seconds in, we pan up, you know, and try to get all that timing right, and then clear out all the actors, clear out everything, do the clean plate, and just do that crazy handheld shot with just, you know, the camera operator. And it was a nightmare, honestly. But that to be able to have something on set, you know, where we can all be talking about the same thing and kind of commit it to memory, it was crucial, you know.
And especially on environments like that where the planning is so crucial for one-shots and limited lighting and all that kind of stuff. The technology you talked about earlier, scanning the environments that you're
that point cloud thing was awesome.
Yeah.
I loved that thing.
We did that a couple times for a couple different scouts, and we'd either use just the point cloud, but we usually
use it for lineup, right? For you guys, right?
Yeah, so we'd line up different assets, make it look more like digital environment rather than a bunch of point.
What I liked about it is I could tell the grade of the ground, because a lot of times we'll just go out there and we'll get some rough measurements, but it never quite lines up. But when I have that point cloud, I can see where the grass is, I can see where the tree is, you know, I can really kind of understand where that camera needs to be, 3 feet, 2 feet, or whatever, you know?
Yeah.
It was, I loved it. Yeah, and that was a real challenging, because we had 3 days to do that scene. You know, we were constantly up against the time pressures of what we had to do for this movie.
And then apart from the environments as well, like a big part of this show in terms of the assets was all the crowds that we had to deal with. Like just in that one, you had crowds of apes, you had crowds of zebras, you had crowds of humans, all completely different, animation styles and such. So making sure, you're running at a rate that's workable as well as.
I guess what you were looking at there, that was the post-viz side of things, right? And that was super crucial for us on this movie, because you have to imagine, like, when we pick a shot and we pick a performance, which sometimes are 2 different shots, by the way, we have to keep track of, to be able to look at something and make that decision, because I will not see the results of that decision, those choices, for like 6 months. And by the time that comes back, the shot comes back, it's too late to change anything. So the post-viz process from you guys was like really, really, it was even more important than the pre-viz on this stuff. Yeah.
Yeah, with the one of the things that's really fun about previs, and my job in particular, is that all the animation you saw in that of all those people running and the apes running, that was all me and one other guy in a mocap suit
Awesome.
at our office.
Like a little connector or whatever. Or I mean, the XNs, is that what you're using?
No, we have a
volume.
motive stage.
That's awesome.
Yeah.
Unfortunately, we don't have that behind the
We
scenes.
don't
would've been
have
awesome.
any behind-the-scenes footage, unfortunately. But but like that scene in particular was a really fun one to, you suit up and then you're like, okay, I'm in the water. How, without any water or anything really like weights or anything, because we just kind of run on a pretty tight budget when it comes to those things. And so it's like, all right, well, I'm just gonna kind of like act like I'm running through the water and drag my feet and stuff. And the mocap process, we did, I think, only like 3 shoots or something for this whole, like for previs and postvis. But it was this thing where we'd kind of start blocking out the previs, figure out roughly what we needed, and then we'd do like a big day with a huge shot list and like a kind of a grueling shoot where sweat is just like dripping off my face and like drying my eyes with a towel because we need to get like, it's kind of
minutes and minutes and minutes of stuff.
Right, and then you have to like set up the mocap stage, suit up, break it down at the end. So it takes it's a process. And so on a previs budget, you try to get as much motion in one day as possible.
Funny enough, it was very similar when we were going on stage too, because there's about 35 minutes of full CG, like virtual production type stuff in the movie, where we're just on stage. We're just doing the mocap thing, and it's it's a fairly big stage. It wasn't huge or anything. We had that same problem though with the water. How do I do with the water? How do I deal with that? And so all the stunt team and everybody, they figured out, okay, they're gonna put some bungees on their legs and they're gonna run. Of course, they only go so far, and this was not working. And I had to like capture this scene, which is the end scene, if anyone who's seen the movie, when the whole facility is flooding and they're kind of wading through the water and pushing through, Like, how do you capture this stuff? And so what we ended up doing is I was like, okay, take these freaking bungee cords off. And there was a 20-pound sandbag sitting over there. I strapped it to their thing. I took some duct tape, and I literally taped these 20-pound bags to both their feet. And they're just walking around on the stage, doing this kind of thing. And it freaking worked. It looked so good. By the time we got the captured stuff back, of course, they had to do some stuff to help it, but it was like that's what I love about the mocap process, and what we can do here is that you can really kind of, bring out all these little tricks, even to the point when they're floating away. I mean, it's crazy. It's like a $200 million movie, and I've got my actor on a swivel chair, being pushed around the set. You know what I mean? And she's going, "I'm drowning." So I love like making stuff like this, where it's just kind of run and gun, putting together with like bubble gum and and toothpicks. Anyway, it's cool.
So one of the processes that we just touched on was the post-viz process. So pre-viz, you animate all this stuff. You can do motion capture and stuff to put it all together. To inform the shoot and for that creative process, to facilitate the creative process. But once you shoot, like Wes was saying, like 6 months or something before he sees like one of the shots.
Yeah, because you have to make decisions. You have to we have a schedule to hit. And it's like, you need to sign off on 20 shots this week, and you have to choose the clean plate that you want to use, which sometimes doesn't match the shot that I'm cutting with, which is a pain in the ass. And then sometimes I have to change a different performance take or something like that. And so we're making these choices, and you're just hoping that the way you see it in your head and the way you think all the pieces are going to line up, it all works. It's very much like designing a puzzle piece by piece, but separately. And then you don't really put the whole thing together until like the last month or two, and you're just like praying that it all fits together. It's really wild.
Yeah, so one of the ways that PostViz helps productions is by putting in temporary VFX into the plates that they'd chosen on kind of a much tighter budget, and working with the editorial team to basically they give us like a cut. We start working through shots. They cut it back in, realizing what's working, what's not. Maybe it's somewhere in there it's like, oh, we got to add this whole other beat here.
Yeah, right.
And so it's like this iterative and very kind of collaborative process of back and forth. What do you think about this? Oh, what do you think about this?
Yeah.
That kind of thing. And we worked with Dan Zimmerman, the editor, and his team to really kind of hash out a lot of those things. one of the first sequences, I think it was the first sequence we post-vizzed, was the intro to Proximus Caesar scene, which we will show in a moment. And that one really was like the kind of the epitome of post-viz, where we got, it was before we met, you know.
I was still shooting, I think, when you started.
Yeah, you guys were, that's right. Yeah, so Dan, he sent us like a cut that was like, I felt like it was like 11 minutes long or something.
It's always too long.
Yeah, but it was 11 minutes of just empty plates.
Yeah.
And like we had Kevin, and Owen, some of the actors in some of the plates for the performances, but then we would just cut to like an empty yard, and there were like some people in like
imagining
sweatshirts.
Because I mean the idea is there's hundreds of apes.
Yeah.
We don't have hundreds of extras out there. We also didn't have all the full set. We have a fairly significant set, but it still wasn't enough. And so, like, are we framing right? Is it high up enough to see that wall in the background, that kind of stuff? So, yeah, the post-viz was crucial.
Yeah, so it was, so when we first watched the cut, we were all just kind of watching it. You know, we're all working remote, so we're all watching it like
what
on
is
Zoom.
this?
And we're like, I think that there's supposed to be apes here. Are there supposed to be 10 apes, or is this a representation of the whole crowd? And it started this process of we know that there's an ape crowd here, but how big? How far is it? Like an endless ape crowd all the way to like the end of the set? Are there apes like up on the walls? Is it just right around his like podium? And so a big part of the process at the beginning was just establishing the size of the ape crowd.
Figuring it out. Yeah, totally. And that's why I think it's so great about, especially Unreal, because you actually kind of lit it pretty well. You know, and so it actually fit into you could watch the experience, the movie, make all your choices, you know, without like a bunch of gray shading everywhere. You know what I mean? Like it worked really well.
So yeah, we'll watch that.
This way again. You're like, crap, is this gonna work?
So the crowd that you saw in there, you know, it was a lot of work to establish the size of the crowd. But then the next task for us was that this is an entire crowd, and they're not just going to be standing there the whole time. It was like, what are they actually doing? Like, what's the mood of the crowd? And so on one of the motion capture shoots that we did, there was just a lot of us, like me and one of the guys, like, whoa, whoa, and then like, oh, and doing like that kind of stuff. Some of the stuff that we saw, some of the stand-ins doing in the plates. But we kind of ended up building essentially kind of like a mood board, but of motions. And in Unreal, we built it out so that in subscenes, we had different versions of the crowd. And so we would build out like 10 or 12 guys, all with their mocap like slightly offset so they weren't all synced up. And then we would, in our level sequencers, duplicate it, move them over,
little clusters.
Offset, and then we would build the cluster until we had like, eventually we landed at like 600 to 700 apes, like something like that. So we would build like this you know, ape crowd of 600 to 700 apes. And in some instances, like when it's the next beat, they all have to bow now. We would grab our bow animation and we would just swap out animation tracks just over
and actually
over.
The offsets would still hold?
Yeah, all there positional offsets would hold, but and artists would have control of the timing. They could it was a sub scene, so you could grab the sub scene and just slide it around in the shot range. But you could also duplicate it and go in and be like, oh, this guy's bowing too early, so I'm just gonna adjust.
That's where we need some AI help.
Yeah,
make that guy alive.
And but the crowd also, you know, like there was the crowd listening. And then there was the crowd watching the door. And so then it was like,
they were a character in the scene. They weren't just filler.
Yeah. And so there was, there were times where the discussion was, do you just start from scratch and build a completely new crowd all facing the same direction? Or is it faster to just go in and like select them all and type in like 30 degrees and then just kind of like offset them? But using Unreal, it was all live. And so all the animation stuck, like all of their like jumping around animation was still there. You just positioned them differently in level sequence and you just saved it. And then you could give that to the rest of the team. Hey, everybody, for these next like 10 shots, use this new crowd. And I feel like there had to have been like 12 different like 700 ape crowd.
And we kept changing the number too. Oh, this is too dense. Oh, this is too light. You know, so we were trying to, there's a lot of work going into that thing.
Yeah. And we kind of knew that was coming based on other scenes and stuff. Obviously, this was post-viz, so we kind of saw what was coming and had different levels of of detail for each of the apes. We obviously had our heroes that had kind of their own grooms, their own textures and models.
But
and
you
stuff
also
like
had all
that.
the environment stuff in there, which you kind
That's
of can't
right.
tell in this because it looks pretty good. But like the ship back there, we didn't build that much ship.
Yep.
You know, and all the wall back there. But it was really helpful for us to see what is it going to feel like. You know, and we decided what the wall height was with you guys.
Yeah,
too.
yeah, that's right. The wall height, the wall shape, because you guys had filmed a bunch of like drone shots
Yeah.
Of basically a big old kind of.
And I cheated in the shots, but
But yeah, it was like the front door, the big iron door.
which we built. That was real.
Yeah, that was real. And then it was
massive.
a bunch of sand and tents, and then there was the wall kind of over to the right where the apes lived.
Yeah.
Like that was real, but the seawall.
And the tent stuff wasn't the big giant. Big
Yeah.
tent thing. Yeah. It was a massive set, but it wasn't even close to full. You know, wow.
Which is pretty different than the point cloud, you know, for a very natural environment that we got. So pretty different than like seeing a location scout, going for some previs, instead getting the art department scan and kind of clean up model of what they had actually built for the shoot, and then working on processing it, getting it down to real-time, you know, rendering performance.
How much is that? I mean, we're using nanite and stuff. How much was that?
I mean, this was Unreal 5.0 point whatever. So it, we were kind of like working on where nanite would work and where it wouldn't. You know, it wouldn't. We didn't have anything super helpful for foliage still. Like that wasn't even a feature yet.
Yeah,
that was
right.
still not worked out. So a little easier now probably to handle all that.
definitely.
But yeah, probably some modeling processing and then just getting the textures on there to match what we see in the footage. And then yeah, all the extension, figuring out how the seawall is gonna
You had to track
look.
all the cameras and yeah.
Oh yeah.
And then
Did you use any of the kind of machine camera stuff that they had to track?
No.
We just tracked the
just
actual
tracked it,
shot.
yeah.
So we had this cool thing on the rig on all the shots. We had 2 machine vision cameras, stereo, underneath the lens. And they were all super wide lens. So while we were shooting our shot, we were also getting this really, really wide angle view of the shot as well, which they would come in handy for tracking the cameras, but also they had some process where they could take the 2 cameras and they would generate basically a 3D mesh that we can look at for lineup purposes. It was like fascinating. It was like one of the first times they did it, but yeah, clever stuff.
Yeah, the other cool part about this environment specifically, you know, we're extending it, and we kind of get to see a lot of the area around there throughout the course of the movie, where they're walking to the encampment on the beach, even so far as out that shot of the eagle kind of flying to the coast.
Yeah, that whole sequence there, that whole set, almost everything got replaced to be full CG from what we shot. So when you watch it, it's pretty wild.
Yeah, and neat to have it kind of all be in basically real-world positioning, kind of that whole sequence going to the ship. The interiors were kind of cut out to be separate environments, like the interior of the main ship and then the interior of the silo. And you've got the encampment and kind of the hut or the tents for the apes. And we know we've got some shots out there kind of looking out to the ocean with all the broken down oil rigs and stuff like that. So.
Yeah, there was a lot of kind of back and forth about like how much wreckage is out in the ocean, and at like one point it was like it's full of metal, but
It started looking like shit. So you just said, let's pull it back, and it looks a little prettier.
yeah, and then also the big cliff that they climb up to the end.
Yeah, that was another really cool set extension. They built the very climactic scene where they're all kind of turning on Caesar, and they've got the top built where they exit the silo, but we got to figure out the rest of the cliffs, and we know they climb up them earlier, so we got to figure out the height there.
That was one of the first things that I built. You know, it was like the thing is like we were trying to figure out what the hell is this thing gonna look like, and we had some concept art, whatever. But then I just opened up Unreal and grabbed some of those mega scans, cliffs, and started making this little thing, and I stumbled upon the design of the thing, and then I hand it off to whoever, and it kind of makes its way through the system,
Yeah. Such a good note on just like the Unreal suite of resources on a previs and post-viz timeline, like anywhere you can pull from Megascans, or, I think we probably bought the packs for the zebra and the eagle, and then we make the modifications we need to, or add some animation cycles.
That's right. Yeah. So for both the eagles and the zebra. So Wes had gotten like an eagle, like a bald eagle or a golden eagle.
Yeah, it was awesome.
Yeah.
I had all animations in there, and that's how I did the opening shot.
Yeah.
I got him flying, and I had never done it before, but the timeline thing, you take the clips and you can kind of blend them, and it was awesome. I was like, oh sweet, I'll have them flap right there, and it was awesome.
Yeah, and so you handed that off to us, and we were like, oh, we're gonna rig our own eagle and stuff. But then we saw like how Wes was doing it, I was like, well, let's do it this way.
Let's do that.
Yeah, and so
Dirty,
like,
man. Do it quick.
So in Maya, for both the zebras and the eagle, I think that was the only two things. I think maybe we had some birds that we did, some other birds. But we had the skeletal mesh that we would either we would rig as just like a single or two joint prop in Maya, so that we could frame up a shot, position, like animate the position, but it's just like this with its feet sticking out and everything. And then once we got into Unreal, we would start applying animation to it because it's a skeletal mesh, and so you can exactly. Like make it flap 3 times, and then it's gonna like glide for a little bit, and then it comes in for a landing, and you can time all of that out, all based on kind of this, like not really a motion path because it's baked out animation, but kind of the motion path you'd set in Maya. And then same thing with the zebras. We knew that we had a zebra crowd. We didn't really know how many zebras. I feel like we were like, oh, let's make it like 1,000 zebras, But we made like a 10 zebra rig where it was just like the zebra frozen in one pose. It's just a static mesh in Maya, and we would just drive it around, make sure the speeds and stuff were right. And then in Unreal, we had like a blueprint where it was set up with 10 skeletal meshes, and those meshes were like hidden. And in there, we could be like, oh, let's put the marketplace asset run cycle on it. But then here, oh, it needs to jump to the side, and there's no marketplace asset for that, so we'd have to animate that, throw that in, and then it was like, oh, we want it to kind of them to have this like leaping kind of feeling, so we would animate those, and so it was definitely a mix of like animating in Maya, but then also animating in Unreal, or like kind of taking like crowd work. Crowd work's Unreal, but the shot design is Maya, and but that's a little bit different when Wes is involved, because on the kind of climactic scene at the end, there was I remember it was one of those things where like a message that, it's like whenever we get a message like this from you where I was like, I stayed up all night. If that was like, if that's
go check the perf force. It's on the
like,
thing.
Oh no.
It's labeled Wes. It's somewhere in there. You'll find it.
And Wes had blocked out like a bunch of shots with just like a bunch of static apes. And it was for the whole kind of climax of how, kind of like how like the last part of the movie, the fight between Noah and
What's funny is that zebra thing, it could have been way worse. Because there was a version of the script, when it first came in, that scene, there were giraffes in there, and there were like rhinoceroses in there, and it was crazy. And I was like, guys, we're not doing this. I'm gonna limit it to one, a zebra and maybe a bird, But it could have been worse. But also what's funny about that, because I had originally had a different idea for that scene. You remember that? The big horse chase?
Yeah.
So I had this basically what I wanted to do was I wanted to do the coolest freaking car chase on horseback that you've ever seen. So I had this awesome, chase where they're like, pulling on her, and it's just going back and forth, but it all takes place in the remains of old freeway ruins. And so things are crumbling around them. It's like the ancient kind of Roman, aqueducts or something, you know what I mean? And it was this awesome thing, and they got on a bus, and the bus was collapsing, and it was like $16 million. We didn't even really get far down that process during the prep. It's like, you have to cut this, because we had to keep the movie down to like, it ended up being 163, something like that, which was a lot cheaper than the previous movies. But you make those kind of concessions and move forward. It's kind of the process.
That is
previous some of that.
Yeah, we did. Yeah, we previewed that, and it was definitely one of those ones where like halfway through the previous process, you were like, guys, keep going, but I think this whole thing's gonna get cut.
I'm gonna try. And I made the good fight. It was freaking awesome. It was a really good scene. But whatever.
So when we were talking about you staying up late, sending us files, we like just open them up, watch them, and it's like, okay, it's like immediately that's part of the collaboration that Unreal like helps you helps facilitate, is that we watch it and it's like, oh well, like only 2 of these guys are animated, but I totally understand what is going on in this shot. And so we would take it, we would like swap out Wes's like crowd with our crowd that's got mocap on it, and then we would hand key or put motion capture on the main characters that Wes had animated, but then they're Wes's cameras.
Yeah, the thing I care most about personally for me is like I care about lighting and camera. You know, for the most part, I can kind of imagine as a static guy sliding across the frame or whatever, just to figure out blocking and stuff. But like, if you can get that sense of the camera and it feels real and feels live, and then you have a sense of mood and atmosphere from the lighting, it does a lot of the job. You know, so I put a lot of attention on that stuff.
Yeah. Cool. Well, I think we're gonna take us out with a post-viz reel. So you're gonna see after the movie is shot. We only prevised like 5 sequences. It was like the opening climb, which Weta, there was like whole chunks of it that Weta.
Oh, it was.
You guys went.
We had like a
way
20-minute cut of that thing.
Yeah.
Yeah, and eventually it got whittled down, but rightfully so.
Yeah. And then we did the Marauder attack, human hunt, and then the scene where Raka and Noah meet. But when it comes to post-viz, it got a lot bigger.
Yeah, I loved it. I love that part of the process.
Cool. So we'll show you guys that, and then we can do some questions.
So.
Sorry, guys. Hang tight.
I see a plan.
That's it going.
Shot with the bird flying in, that shot was a perfect example where I had that in the cut for so long, and then I get these shots back from Weta, and it was never right. And I kept saying, back to the previs, do the previs. I don't know if they ever contacted me, but I told them, get in touch with Casey and get the data and stuff, because like you got that shot just right. And eventually they got it, but I love that shot in the theater. Just something about the structure of it and the pacing of it. Every single time I watch it in a theater, I actually jump because it actually feels like it hits me. And the way the sound kind of goes, and it's one of those little tiny shots that you'd never think anything of, but I just always loved.
Awesome. Well, yeah, if you guys have any questions.
Ask you if you considered capturing finger during previs or not, or what considerations you made not to capture them.
Capturing figures?
Yes.
Yeah, so I think that there was...